Hello, everyone. I have the problems next to me. Um, yeah, and I'll be doing it for, I estimate, 4 to 5 hours. Could go longer. So yeah, hello. What are you guys doing? Yeah, it is indeed me, Keenan. There is no setup that I found that would not have a large amount of, I guess, furniture on the side. So you're just gonna have to deal with the entire right half of it being the bottom shelf. Yes, this is the Harry Chen. Am I loud enough? Can you guys hear me? Louder? Um, sure, I'll go louder. Actually, I'll just get closer. That probably works just as well. This is the sound device. Okay. How to donate money? I don't have anything set up. You can donate bits, I think, because that isn't technically money. Oh yeah, affiliate. Whatever. I don't need money from this. I just need, I guess, math. We're 2 minutes in. I'll write down the first integral. Why not? Mo, that's kind of blurry. Can you guys read that? Okay, yeah. I brought a pen. Why is this potato quality? Yeah, I can't increase the camera quality. This is on an iPhone. So, yeah, I can't. I don't think OBS works on the phone. I guess I could try to edit it on my computer while it's happening, but I don't know. PowerPoint? You guys can just look up the PDF yourselves. It's Blackpenredpen. On the website there's what no, I don't have a stylus pen. Plastic? Uh maybe Rashad, we can maybe have a face reveal at the very end, just not now. With a rubber tip. Um Let me go ask my parents if I can get one. I'll be back. Okay, I'm back. Um, yeah, I don't have a stylus, unfortunately. Why would you use integration on parts on this one? Oh, we're starting in a single minute. Okay, you guys have any suggestions before I begin? I would love to use OBS, but I don't really have a way. No, it's literally just Xtile. Oh, it's 1 o'clock, guys. Welcome to the, we'll be doing 102 integrals in like, hopefully 4 to 5 hours, I don't know. Yeah, so we'll be using the exact same integrals as Blackpenredpen used in his integral marathon. Do you guys want me to do this with no water? No food, no water? Because I know Blackpenredpen didn't have water when he did it, so... Well, I wasn't gonna plan I wasn't planning on eating anything to begin with. I do have water next to me though. Not sure. If I get severely dehydrated, I will start drinking water. I'll do that. Okay. I'll drink water. I will drink water. Let's begin. So this is the very first question. Integral of tangent to the 5th power x times secant to the 3rd power x. When you're dealing with tangent and secant, there are really only two things that apply. The derivative of tangent of x is secant squared of x, and the derivative of secant of x is tangent secant of x. Is someone actually called 69 Legend? How do I kick people? Here we go. He is banned. There we go. Okay, let's continue then. Yeah, so there are two derivatives that really matter in terms of there are only really two derivatives that matter, and that's the derivative of tangent of x is tangent of secant squared x, and then the derivative of secant x is tangent secant. So we can try using the tangent one. However, there really is not a good secant squared anywhere in here. So we won't be doing that. And basically the power of the secant is always going to be odd, so secant squared doesn't really matter. Instead, we're going to try to use the other one, that the derivative of secant is equal to tangent secant. So we need a tangent secant. Well, we already have tangent secant, but we probably want to only get one tangent, so we have a single variable and not a whole bunch of them. And so we'll use the identity that we're going to use the identity that secant squared of x is equal to tangent squared of x plus 1. And so we'll just substitute that in for tangent twice, and so we'll get this is equal to integral of secant squared x minus 1 secant squared x minus 1 times secant cubed x times tangent x dx. I'm not going to turn the chat off, nor am I going to get mods. I don't really feel like it. And then, yeah, so we'll let u equal secant x, which means du is equal to secant tangent x dx, and then we'll substitute this in to get integral of u squared minus 1 times u squared minus 1 times u squared du. Wow, this kind of sucks. Okay, so yeah, we'll just expand it and use power rule. What is VOD? Yeah, Radiant Cheddar, this is automatically going to be recorded. Video on demand? Is that... Yeah, it's already... It's going to save the video already. Yeah, it's already on. It saves the video after the stream ends, so I will have access to it. And so this is equal to integral of u to the 6th power minus 2u to the 4th power plus u to the 2nd power du. By power rule, this is going to be equal to 1/7 u to the power 7 minus 2/5 u to the power plus 1/3 u to the cubed plus c. And then, of course, we can't just leave it like this. We got to substitute u back in. And so 1/7 secant 7th x minus 2/5 secant 5th x plus 1/3 secant cubed x plus c. Final answer. Cool. Let's move on to the second one. If at any point you guys have questions, just ask it. That's kind of the point. Or, if it's wrong, definitely point that out. Next one. Integral of cosine 2x over sine x plus cosine x. This one's a lot nicer, I think. We'll use the identity that cosine of 2x is equal to cosine squared x minus sine squared x. And yeah, so we have the integral of cosine squared x minus sine squared x over sine x plus cosine x. The top is difference of squares, and so this is going to be equal to the integral of cosine x plus sine x times cosine x minus sine x over sine x plus cosine x dx. And then we have a sine x plus cosine x on top and a sine x plus cosine x on bottom. So, boom. Oh, it's kind of a delayed boom. Okay, well, and so we're just left with the integral of cosine x minus sine x, which is pretty easy to do, just sine x plus cosine x plus c. Final answer. I swear it gets better. Okay, guys, I'm just gonna use another paper. I have an entire stack of paper next to me. I imagine that after doing 100 of these, we're probably gonna go through all of them. Question 3. X squared plus 1 over x to the 4th minus x squared plus 1 dx, the integral of that, of course. Okay, so u sub's not going to work. I don't know, we can try factoring. So the bottom is going to be equal to, the bottom's pretty much equal to x squared minus 1 squared, plus x squared? Yeah. You can, of course, just, FOIL that out and get the answer. FOIL that out and you'll see that those two are equivalent. Okay, we're going to use okay, yeah, we're gonna use a big brain move. We are going to divide the top and bottom by x squared. And so when we do that, we get this. And so what you'll notice is that the derivative of x minus 1 over x happens to be 1 plus 1 over x squared. And so, simply put, we'll just do a u sub. And then from here it's pretty easy. This is equal to integral of 1 over u squared plus 1 du, which we know to be equal to the inverse tangent of u plus c. And then of course we substitute back in, so this is equal to inverse tangent of 1 plus 1 over x squared. That's not right. It's equal to inverse tangent of x minus 1 over x plus c. Final answer. Sure, actually, you can DM this. I don't really care. Okay. Next question. Number 4. The integral of x plus e to the x squared dx. This one's actually kind of straightforward. It's... Who is Bebo? I don't know. Hello, Bebo. Okay, and so this one looks kind of ugly. It's actually not that bad. We just have to expand it. So x squared plus 2x e to the x plus e to the 2x, because remember e to the x squared is equal to e to the 2x. And so this dx, and so each of these is not that bad, and so this is going to be equal to 1/3 x cubed. The middle term there, we're going to have to use we're going to have to use integration by parts. And so we'll just do d I, we'll let this be 2x because isolate, so the linear function is x, and then exponential is e to the x, and so we get 2, and then 0, so we can stop there, e to the x, plus, minus, boom, boom, and so the integral of 2x e to the x is simply equal to 2x e to the x minus 2e to the x, and so we'll put that back in here. And then the integral of e to the x is 1/2 e to the 2x. I misspoke there, but you know, you get the gist. Tree 65 420 is Eric, really? Eric? Anyway. Yeah. This looks about right, I think. This is not a pretty answer, but it is an answer, so yeah. Question 5. This one's a doozy. Okay. The integral of cosecant cubed x secant of x dx. Eric, these are from the Blackpenredpen's 100 integral challenge, so I'm just going to be using that. Yeah. Okay, and so we don't really like cosecant x and sine secant of x. Not really when they're together. That's kind of messy. And so we'll rewrite this as 1 over sine cubed x cosine x dx. Okay. So it looks like there is not really anything that can be done with this, but we actually do have a little bit of freedom here. Remember that 1 is equal to sine squared x plus cosine squared x, and so we'll use that, and we get sine squared x plus cosine squared x all over sine cubed x cosine x dx. And so now we can just kind of split the fraction apart and evaluate them each individually. And so we have 1 over sine x cosine x plus actually cosine x over sine cubed x dx. This is gonna get really messy. Okay. For the left one, we are going to use the exact same trick. Keenan, some of these I have done because I watched just a lot of Blackpenredpen videos. So this one I think has appeared literally before in one of his videos, so I know how to do this one. Yeah, it's a lot of these I've never seen in my life, so that's when the challenge will start to ramp up. Okay. And so the left side we're just not going to deal with right now. We don't really, that's not something we're going to worry about currently. We'll deal with the right side first. And so, let's see here. We will take it back into the cosecant world, because why the heck not? Cosecant x squared times cotangent x. And then this is actually very solvable. The right side will, if we let u equal cotangent x, du is equal to negative cosecant squared x dx. And so we just get that this is equal to the integral of 1 over sine x cosine x minus, dx minus 1/2 cotangent x squared. That one's, can't read the integrals anymore. I don't know what happened to the camera quality. I think it's just been going down and down. Whatever. You can listen to my voice, Keenan. I'll read out the integrals for you. So yeah, the integral of cosecant squared x times cotangent x is equal to negative 1/2 cotangent squared x. So that's just a u sub on cotangent x. And then, yeah, we should find a way to fix this. I'm really not sure what the solution is. I didn't expect the camera phone quality to be this bad, because on the phone itself, the quality seems to be pretty okay. I don't know what's really happening on the stream itself. It's just kind of destroying it. What if I just use Desmos? Anyway, yeah, and then so for the left one, the 1 over sine x cosine of x. To solve that, we will use the same. We'll use the same thing again, because I don't know. I guess we hate ourselves. Integral of sine squared x plus cosine squared x over sine x cosine x dx minus 1/2 cotangent squared x is equal to the integral of, we split this back into 2 again. Stats? Where's stats? Oh. Okay, well, anyway, yeah, so we get, tangent x plus cotangent x dx minus 1/2 cotangent squared x, and then from here we just kind of, this is not going to be pretty, but yeah. And so finally we get this equal to ln plus secant x minus ln cosecant x minus 1/2 cotangent squared x plus c. Yeah, so that's the solution to this one. We will move on. Let's hope for some easier ones, or simpler ones, or ones that just aren't as cluttered as that. Number 6. The integral of cosine of x divided by sine squared of x minus 5 sine of x minus 6 dx. The derivative of sine is cosine. No, Keenan, I don't really know surface integrals. Yeah. I'm number 5, 19 minutes in. You are correct. At this rate, it'll take me 6 hours. Okay. I don't really have time to work until 7 o'clock, so yeah, let's go faster. We'll let u equal sine of x, because that means the derivative of that du is equal to cosine of x dx. And so this is equal to the integral of 1 over u squared minus 5u minus 6 du. We will partial fractions of this. A over u minus 3. That's not it. Sorry, u minus 6 plus b over u plus 1 du. And then that means let's use the heavy side method. So to make the denominator of a equal to 0, u would have to equal 6. And so that means u 6 plus 1 on the b side with 7. So to make a times 7 equal to 1, we have to use a equal 1/7. And then we do the reverse on b. We let to make the denominator of b, the b term, equal to 0, you have to equal -1. And then we plug -1 into the a side, so a -1 minus 6 is -7. To make -7 times b equal to 1, b would have to equal -1/7. And so we have minus 1/7 u plus 1 du, and then this is very simply just it's just this is just basic power rule now, or not power rule, but it's 1/7 ln of u minus 6 minus 1/7 ln of u plus 1 plus c, which is equal to 1/7 ln of sine of x minus 6 minus 1/7 ln of sine of x plus 1 plus c. Final answer. What are you guys arguing about? I'm green. What? Number 7. The integral of 1 over square root of e to the x dx. This is actually kind of simple, because this is just the integral of 1 over e to the x to the 1/2 power dx, which is equal to the integral of 1 over e to the 1/2 x dx, which is equal to the integral of e to the -1/2 x dx. And then we can do u sub if you want, but it's not. It's just equal. It is equal to -2 e to the -1/2 x plus c. Next question. Oh, this is not AP review. This doesn't really apply to the AP exams at all for the most part. A lot of these are like way harder than anything the AP exam will give you. Yeah. Next question. The integral of e to the x square root of e to the x minus 1 over e to the x plus 3 dx. Well, we have an e to the x in front of everything. And so we can let u equal to e to the x, or something like e to the x, and then kind of go from there. And so yeah, let's let u equal to e to the x minus 1. That means du is equal to e to the x dx. And so this becomes equal to the integral of just square root of u over, well, remember up here that e to the x is equal to u plus 1. And so we have eu plus 4 in the denominator here, du. This is terrible. Okay. We will let v equals square root of u, which means dv. There's something wrong with the stream. Can you guys... What? Did the stream stop at all? Wait, no, it's just loading on my side. Okay. dv is equal to 1 over 2 square roots of u du, which means, this, since v is equal to square root of u, this means that dv is also equal to 1 over 2v du. And so this whole thing is equal to the integral of 2v squared over v squared plus 4 dv Oh, hi, hello, everyone. What is the link? Oh yeah, hi Kevin, whoops. Okay. And so we can just do long division if you want, or I'll just do this kind of quickly. It's 2 minus 8, I think, over v squared plus 4. Yeah, dv. And so we can just do both parts as equal to 2v minus tangent rules, so this would be 8 over 2 inverse tangent of, I think, v over 2? Is that right? That might not be correct. What are you guys doing? What is that YouTube link? Whatever. I'm sorry, let me check this for a second. Something about it seems off. I'll get back to this one. I don't think I can make a huge stop to check this. I think this is correct. I of course have to substitute stuff back in. Actually, yeah. Anyway, so yeah, this, when we substitute this back in, this is equal to 2 square roots of u minus 4 inverse tangent of square root of u over 2 plus c, which is equal to, Jesus Christ, 2 e to the x minus 1, square root of e to the x minus 1 minus 4 inverse tangent of square root of e to the x minus 1 all over 2 plus c. Okay. I really feel like I did something wrong here. I'm just gonna take it as it being correct. Okay. Next one. 9. The integral of 1 over x plus square root of x dx. Why not? Well, let u equals square root of x, which means du is equal to, as we covered before, 1 over 2u dx. That is very commonly used. Who are all these people? Who's Charmander 33333? These integrals are from the Blackpenredpen 100 integral challenge. Anyway, so once we substitute this back in, this is equal to the integral of 2u over u squared plus u du. Because of course x is equal to s squared of x squared. So in all, this is equal to the integral of the u's cancel out. So 2 over u plus 1 du, which is equal to 2 natural logs of u plus 1 plus c, which is equal to 2 natural logs of square root of x plus 1 plus c. 102 IMO problems, God's sake. Okay, next question. Okay, thank God, I thought it was the wrong question. Question 10. The integral from -1 to 5, a definite integral, of x minus 3 dx. We'll just draw this one because that's so much easier. So this will be 0.3, 0. This is 0.5, 2, and this is -1, 4, I guess. Yeah, so we'll just connect the dots here. For this one, the side length is 4. The side length of this is also 4. And so the area of this triangle is 1/2 4 times 4. And then over here, the side length of this one is 2, and the side length of the horizontal is also 2. So plus 1/2, 2 times 2, and that's equal to 8 plus 2, which is equal to 10. Final answer. Yeah, not all of these are like super bad. Some of these are like, some of these are a lot easier than the other ones, but I don't think there's any actual particular, like, the way the difficulty is organized. I think they're kind of random. Because I briefly looked over some of them, just to make sure, I guess they were all there. I don't know. And yeah, some of the ones at the end were pretty easy for some reason. Okay, this one should be pretty easy as well. Integral of sine of x over secant to the 2019th power x dx. Well, we don't like secant. We'll turn that into cosine. So the integral of, it actually just becomes sine of x times cosine of x to the 2019th power. And so, what are these? Well, I'm trying to break this record because I have way too much time right now, and I just feel like doing integrals. And so we'll let u equal cosine of x. Du is equal to negative sine of x dx. And so this whole thing's equal to negative u to the 2019th power du. Isn't that fun? I thought it was e to the 2019th power? Sure. And this is just equal to negative 1 over 2020 u to the 2020th power plus c. What, was this video released in 2019, right? No, I've not looked at any of the English lectures, Kevin. And so this is equal to negative 1 over 20 cosine to the 20/20th power of x plus c. That is... Why? Why not? Send this video to all the people you tutor. I don't think this is a very good educational tool. This is just kind of me doing integrals a lot. Yeah. This is not a good educational tool. Like, it isn't. 12. Integral of x sine... Well, okay. It's a good educational tool if you are taking calculus 1 and 2 at, like, college. Because some of these actually... A lot of these actually are, like, more common integrals in college. Which is, I guess, what this was supposed to do. I mean, the person who taught this was, teaches at a community college. So, like, these videos are designed for his students. So, yeah. What the heck, CJ? Okay, so number 12 is the integral of x inverse sine of x over square root of 1 minus x squared dx. Notice that the derivative of sine inverse x is square root of 1 over 1 square root of 1 minus x squared. And so we'll use a u sub. U is equal to the inverse sine of x, which means du is equal to 1 over square root of 1 minus x squared dx. This also means that x is equal to the sine of u, because we just take the sine of both sides. Okay, and so using u sub, this becomes actually just the u sine of u du. And so this one then we'll use integration by parts. I feel like you could have used integration by parts at the beginning, but this just is easier to deal with. Why are you guys asking about OMO here? It's just... Okay. So by isolate, the thing we're deriving is going to be u, and the thing we're integrating is going to be sine of u. And so it becomes 1, 0, negative cosine of u, we're integrating, and negative sine of u, plus minus, blah, blah, blah. And so this is equal to negative u sine of u. That's not correct. It's equal to negative u cosine of u, plus sine of u, plus c. Substituting u back in, we have, this is going to be weird, negative sine inverse of u times cosine of sine inverse of u plus u. Wait, why am I using u? These are supposed to be x's. I'm sorry. Plus x plus c. Yeah, and so we could simplify cosine of inverse sine of x if we wanted to. I don't really want to, so I'm just going to leave it like that. Next question. Yeah, the quality is, it's potato quality, but... What? Yeah, it's potato quality because this is a phone camera, and I guess that's just not good enough for Twitch. So... Yes, we're at 17 already. Wait, 17? Oh, I'm sorry, we're at 13. We are at 13. I was looking at the wrong problem. The integral of 2 sine of x over sine of 2x. This one's not too bad. Remember that sine of 2x is equal to 2 times sine of x times cosine of x. And so this is equal to the integral of 2 sine of x over 2 sine of x times cosine of x dx. A lot of this cancels out, so we're actually just left with the integral of 1 over cosine of x, which we know is just the integral of secant of x dx, and so we have that this is equal to the natural log of secant x tangent x plus c. Who is exodine? Who are all these people? Oh, it's the third? Okay. I'm not going to get tired of talking for a while, I think. I have a lot of water. My throat's not going to get dry, I think. So, yes. Number 14. The integral of cosine squared of 2x dx. So we're going to use one of the first tricks they do not tell you, really, in Calc ABC. I am Evan Chen, really. Anyway, and so this is that so recall that cosine of 2x is equal to 2 cosine squared of x minus 1. If we do some rearranging, that means cosine squared of x is equal to 1 plus cosine of 2x all over 2. And so we'll use this fact to get that this integral is actually equal to 1 plus cosine of 4x over 2 dx. And so from here, this actually gets a lot simpler. Is equal to 1/2 x plus 1/8 cosine of 4x plus c. Yeah, wait, no, not cosine, sorry, sine. 1/8 sine of 4x. So that is our answer, 1/8 sine of 4x. If you were to use integration by parts, you'll actually just end up in a huge loop. I think what happens is you go from cosine squared to sine squared back to cosine squared over and over and over again. And yeah, and you don't, that doesn't help you at all. So 15. The integral of 1, what the heck is this? The integral of 1 over x cubed plus 1 dx. Anyway, and so for this one, not really a whole lot's going to help us here. So we might as well see if we can factor it. And in fact, we can. Remember that the factorization of x cubed plus 1 is just x plus 1 times x squared minus x plus 1 dx. And so we can use partial fractions. In ABBC, we don't actually do partial fractions on anything that has anything that has an x squared in it on the bottom, not just x's. So this is kind of new, and so we'll let this be a over x plus 1 plus bx plus c over x squared minus x plus 1 dx. Heavy side will not work on this. We're going to have to use system of equations. That's fun, isn't it? Roots of unity? How about you don't use roots of unity on this? As much as I would love to take this into the complex world, I don't think we should. And so, okay, so Okay, so we know that 1 is equal to a x squared minus x plus 1 plus b x squared plus x plus c x plus 1. Let's set up a system now. 0 is equal to a plus b. For the x's, there can't be any single x terms, so that's 0 is equal to negative a plus b plus c. And then 1 is equal to a plus c. If we solve for all of this, we should get, let me see. Okay, I'm gonna have to actually work this out. A is equal to negative b from the first equation, which means if we substitute that back into the second equation, we get that 0 is equal to 2b plus c. If we substitute a is equal to negative b into the third equation, we get that 1 is equal to negative b plus c. And then we can just subtract these from each other to get negative 1 is equal to 3b, or b is equal to negative 1/3, which implies a is equal to 1/3, which implies c is equal to 2/3. And then, yeah. And so in all, we get the integral of 1/3 over x plus 1 plus negative 1/3 x plus 2/3 over x squared minus x plus 1 dx. Oh no. This might need another page. Okay, so we can, the left term is pretty easy to do. For the right term, though, that's not so easy to do. Okay. For the sake of right now, we're just going to try to simplify the right one. So this is equal to negative 1/3 x plus 1/6 over x squared minus x plus 1 plus 1/2 over, I'll write this as x minus 1/2 squared plus 3/4. You guys, you can check this is true, because if you expand the bottom of the right term, you get x squared minus x plus 1 again. And then if you combine the fractions together, you should get 1 minus 1/3 x plus 2/3 again. What are you guys talking about? Anyway. And so the reason we did all of this is because on the left term, this one, what we can use is we can actually use, I'm using 1 to 2, I'm going to try to use 1 page per problem. I can also try to do 2 problems on 1 page. That's optimal, I guess. That might not be possible. Okay, and so we can do, the reason we did this is because we can actually use u sub on this one, the left one, and then we can use inverse tangent on the right one. Yeah. Let's do that. we let u equal to x squared minus x plus 1, that means du is equal to 2x minus 1 dx, which which actually does work up there, because this is equal to du is actually equal to 1/6. Wait, I'm sorry. Is equal to 6 times -6 times -1/3 x plus 1/6 times dx. So actually, we do have the we actually do have that on top. So this makes our use a lot easier. On the right one, that's I mean, we can let u equal to what? You can let u equal to x minus 1/2, and then just use the inverse tangent stuff on that. And so all this should be equal to 1/3 ln of x plus 1 plus Jesus Christ y, I think minus 1/6 ln of x squared minus x plus 1 plus oh no, 1/2 divided by square root of 3 over 2 inverse tangents of x minus 1/2 divided by square root of 3 over 2, which what we'll write down as 1/3 natural log of x plus 1 minus 1/6 natural log of x squared minus x plus 1 plus 1 over square root of 3 inverse tangents of 2x minus 1 over square root of 3 plus c. This is not a good problem. I'm just gonna delete that. Let's never see that problem ever again. 16. The integral of x sine squared of x dx. Let's try integration by parts. We'll try integration by parts. Ilate tells us to use x as d and then sine squared. For I, the derivative of x is 1, obviously, and then 0. And then if you guys remember how we use the power reduction formula, or in other words, how we just use the fact that cosine of square root of x is equal to 1 plus cosine of 2x divided by 2. We can do a similar method for sine squared of x to produce the result that sine squared of x is actually equal to 1 minus cosine of 2x all over 2. So the same thing as cosine squared, just but with a subtraction sign. Okay. And so this makes integrating that pretty easy. It becomes 1/2 x minus 1/4 sine of 2x. And then we integrate that thing again to get 1/4 x squared plus 1/8 cosine of 2x. And so plus minus cross, and we get that this is equal to, oh boy, okay, we get that this is equal to 1/2 x squared minus 1/4 sine of 2x minus 1/4 x squared minus 1/8 cosine of 2x plus c. We can combine them together. I don't really want to. We'll just keep going. I really do not understand any of your conversations currently. What is happening? Okay, next question. 17, the one we thought we already got to, but we did not. The integral of x plus 1 over x, quantity squared, dx. We just expand this out, really. So we get the integral of x squared plus 2 plus 1 over x squared, and then we can just apply the power rule. So it's equal to 1/3 x cubed plus 2x minus 1 over x plus c. Sure. Do you want to become a mod, a chat mod? I'll make you a chat mod. How do I do that? Okay, I don't know how to do that. I'm sure. Okay, I'm not making everybody a chat mod. Just like the people I think won't completely destroy the chat. Click his name. Wait. Here we go. Mod user. You are a mod now, Akshar. Feel free to do whatever you think you need to make sure the chat doesn't devolve into chaos. 18. The integral of 3 all over x squared plus 4x plus 29 dx. We will complete the square to solve this. So this is the integral of 3 over x plus 2 squared plus 25 dx. We can let u equal to x plus 2, means du is equal to dx, and so this is kind of still equal to 3 over u squared plus, we'll write it as 5 squared, du. My hand was very well moisturized. How do you tell if it's moisturized in this camera quality? Anyway, and so this is this is equal to 3 over 5 inverse tangents of u over 5 plus c. I think. Okay, I feel like I need to check this. I really do feel like I need to check this at some point. So this is equal to 3. If we differentiate this, this is separate. I'll write it up here. This is 3/5 divided by u squared over 25 plus 1. Is that correct? What? Okay, there's something wrong here. Oh yeah, wait, chain rule. Sorry, never mind. This is fine. Okay, and so we substitute u back in, and this is equal to 3/5 inverse tangent of x plus 2 over 5 plus c. Next question. Question 19. The integral of cotangent to the 5th power of x dx. Yeah, I'm sorry the camera quality isn't amazing. I unfortunately don't really have any other method to do this with, so I've resorted to using my phone as a camera. Okay, cotangent to the 5th power of x. What will we do here? Well, there's not a whole lot to do here. You might as well use the, I guess, the identity. Remember that cosecant x squared is equal to 1 plus cotangent to the 5th, squared of x. Right? And so we substitute that in. We get the integral of cotangent f to cotangent x times cosecant x squared minus 1 squared dx. Okay, let's try expanding this out then. And so this is equal to the integral of cotangent x cosecant to the 4th power x minus 2 cotangent x cosecant to the 2nd power of x plus just cotangent x dx. Yeah, and so for the left one, we can let u equal to cosecant of x, and so that will get rid of the cotangent of x, since the derivative of cosecant of x is equal to negative cosecant cotangent. And then we can do something similar for the middle term, and then for the right term, we'll just use the we'll just use the identity that we already know what the integral of cotangent of x is. Okay. And so we'll let u equal to cosecant x, which means du is equal to negative cosecant x cotangent x dx. And so, and all this is equal to the integral of u cubed minus 2u du, and then plus the natural log of sine of x plus c. This is pretty simple to solve now. So is equal to 1/4 u to the 4th minus u squared plus ln of sine of x plus c. And finally, we substitute the u back in. We get 1/4 cosecant 4th of x minus cosecant squared of x plus ln of sine of x plus c. What are you guys doing? Next question. We are 20% there. It took a little bit more than an hour to get here. This has been going for too long, isn't it? How many people are watching this? Oh, that's a lot. Okay. 20. The integral from -1 to 1 of tangent of x over x to the fourth minus x squared plus 1 dx. This is just equal to 0. This is kind of a troll question. And the reason for this is because if we let f of x equal that, if we plug negative x into that, so tangent of negative x over negative x to the fourth power minus negative x squared plus 1, we get negative tangent of x over x to the fourth minus x squared plus 1. And so we know that it's actually just an odd function. Since it's an odd function, the integral of from negative a to a of an odd function is always equal to 0. So this one's just equal to 0. That was easy. 21. The integral of sine cubed of x cosine squared of x dx. We'll use identity. We'll use identities here. So it's equal to sine of x times 1 minus cosine squared of x times cosine squared of x dx. Let u equal cosine of x. Du is equal to negative sine of x dx. So we get is equal to the negative times the integral of 1 minus u squared times u squared du, which is equal to negative times the integral of u squared minus u to the fourth du, and so this is equal to negative 1/3 u cubed plus 1/5 u to the fifth plus c, or negative 1/3 cosine cubed x plus 1/5 cosine to the fifth of x plus c. What is ROTMG? Flip. 22. You've gone through 21 of these already. Yes, I'm aware that ROTMG is a game. There'd be a shorter way to say that. 22. The integral of 1 over x squared times x squared plus 1 dx. Okay. So this is equal to the integral of 1 over x cubed times square root of 1 plus 1 over x squared. It's not too hard to check that. We just have to take one of the x's out of the x cubed and kind of put that back into the square root, and we can see that that's true. Oh, it's not visible. Okay. And so from here, it's actually, so the nice thing is if we let u equal to 1 plus 1 over x squared, when we take the derivative of this, we get negative 2 over x cubed du. We actually have a x cubed in the denominator, which is exactly what we need for this to cancel. And so this is equal to the integral of negative 1/2 over square root of u du. This isn't too hard since this is equal to 1 over square root of u is equal to u to the negative 1/2, and so we just have negative u to the 1/2 plus c. We substitute u back in and we get negative 1 plus 1 over x squared to the 1/2 power plus c. Next question. Should I use the same piece of paper? Sure, why not? 23. Sine of x times secant of x times tangent of x dx. We know this to be equal to just tangent squared of x, I guess. That's not too hard to figure out because there's like 2 signs in the top and 2 signs on the bottom. Huh. And maybe it would help if we represent this as sine squared over cosine squared. Well, I don't understand any of the chat. Okay, well. Okay, I think I have a plan for this one. So what we'll do is, okay, this is gonna be kind of regret using only one piece of paper for this one. So if remember that sine squared of x is equal to 1 minus cosine of 2x quantity over 2, so yeah, we'll write this as the integral of 1 minus cosine of 2x over 2 all over 1 plus cosine of 2x over 2 dx. And so the 2's cancel out because there's 1 on top, 1 on bottom. And so we're just left with 1 minus cosine of 2x over 1 plus cosine of 2x dx. And here's what we'll do now. We'll multiply the top and bottom by 1 minus cosine of 2x. And so we'll get the integral of 1 minus cosine of 2x squared over 1 minus cosine squared of 2x. By our trigonomic identities, this is the bottom is equal to sine squared, and then we can expand the top. So the integral of 1 minus 2 cosines of 2x plus cosine squared of 2x over sine squared of 2x dx. And so now we can split this fraction into 3 separate integrals. So the integral of, I guess this would be cosecant squared of 2x minus 2 times cosecant of 2x cotangent of 2x plus, what is that? No, this would be, I guess, just cotangent squared of 2x dx. Which, well, this is not. So we know what the integral of cosecant squared of 2x, because that would just be 1/2 cotangent, because we know that the derivative of cotangent is cosecant squared, and so that's pretty easy. The same thing I think is true of the second term, the 2 cosecant of 2x times cotangent of 2x. The real hard part here is actually just the third term, cotangent squared of 2x. However, remember that cotangent squared plus 1 is equal to cosecant squared. And so in reality, we have, let's get it right in here. Plus the integral of cosecant squared of 2x minus 1 dx. And so it becomes pretty easy to simplify this now. So our final answer is we can add the integral of we know the integral of cosecant squared of 2x is already 1/2 cotangent of 2x, so we'll just add that to the front here. So cotangent of 2x minus cosecant of 2x minus x plus c. There is an easier way to do this, isn't there? There has to be an easier way to do this. But whatever, I did it. Question 24. This one's actually kind of infamous. So, secant cubed of x dx. How will we approach this? Well, I don't know, we'll use some trigonomic identities, I guess. So this is equal to secant x times tangent squared x plus 1 dx. So that helps quite a bit. So this becomes the integral of secant x tangent squared x plus secant x dx. Wait, why do I have 144 pings in Discord? What did you guys do? Oh geez, okay. Yeah, and so we'll just take the integral of this. Not too bad. Oh, we can let u equal to, oh, wait a second. Okay, here's the issue. The integral of secant x tangent squared x isn't actually, well, it isn't that easy. So here's what we'll do. We know what the integral of secant of x is, and so we'll write this as ln secant x plus tangent x plus the integral of secant x tangent squared x dx. We'll try integration by parts. So what will we let equal t? Well, the thing we're differentiating can be quite flexible, since a lot of this stuff here is pretty easily differentiated. However, it's not super easy to integrate a lot of them. So the thing we're going to integrate here will be secant x tangent x, and so that leaves us with differentiating tangent x. And so what we get here is that we get we get the derivative of tangent x is secant squared x, And the integral of secant x tangent x is secant x plus or minus. And so we have is equal to ln of secant x plus tangent x plus tangent x secant x minus the integral of secant cubed x dx. Now, we actually, we on the left side here, I didn't actually write it out, but on the left side we do have the integral of secant cubed x, because that's what we were trying to find originally. We can add secant cubed x to the left side and then divide the whole thing by 2. And so we get that the integral of secant cubed x dx is actually just equal to 1/2 ln of secant x plus tangent x plus tangent x secant x plus plus 1/2 tangent x secant x plus c. And that will be our final answer. Next question. (25) The integral of 1 over x square roots of 9x squared minus 1. Well, we can try some trig sub. So that's something that's not really covered a lot in ABBC, or really at all. But we can let x equal 1/3 secant x. Sorry, secant u. And this means that dx is equal to 1/3 secant u times tangent u times du, right? And so if we substitute, if we replace all the x's with 1/3 secant u, we get that this is equal to the integral of 1/3 secant u tangent u all over 1/3 secant u times the square root of secant squared u minus 1 du. So secant squared u minus 1, that's equal to tangent squared u. So I'll just bring this over here as equal to square root of tangent squared u, which is equal to just tangent of u. So in all, we have the integral of 1/3 secant u tangent u over 1/3 secant u tangent u du. So, I mean, the top is the exact same thing as the bottom. So this is the integral of 1, so which we know is just u plus c. So in all, we have 1/3 times the inverse. Wait a second. Sorry. We know that u is equal to the inverse secant of 3x. And so this means this entire thing here is just equal to inverse secant of 3x plus c, and we are done. Oof. We are at our 1/4 mark. We still have 75 problems left to go. Or 77, I think. Question 26. The integral of cosine of square root of x dx. I'll take a water break. For this one, we'll let u equal to square root of x, which means du is equal to 1 over 2u dx, and so we get this is equal to the integral of 2u cosine of u du. Integration by parts, di, we'll let d be 2u, and then I be cosine of u, so it becomes 2, and then 0, and then sine of u, and then negative cosine of u. This one's not too bad, plus minus, and so finally we just have 2u sine of u minus 2 cosine, plus 2 cosine of u plus c. If we substitute u back in, we get 2 square roots of x times sine of square root of x plus 2 cosine of square root of x plus c. That wasn't too bad. 27. The integral of cosecant of x dx. Tofu stream. Sure. Do you guys want to see the actual mechanism behind why the integral of cosecant of x is just ln of sine of x? I might as well show you guys. So this is equal to the integral of 1 minus sine of x dx. If we multiply the top and bottom by wait, is this the actual one that does that? I'm sorry. Forget this. If we multiply the top and bottom by cosecant of x plus tangent of x, we get that this is equal to the integral of cosecant squared of x plus cosecant x tangent x over cosecant of x plus tangent of x dx. So if we let u equal to the bottom, cosecant of x plus tangent of x, we get that du is equal to negative cosecant of x tangent of x minus cosecant squared of x dx. Well, if you notice that this the du happens to be very, very similar to the top. In fact, it's just the negative of it. So in fact, this is actually just equal to integral of negative 1 over u du, which we know is just negative ln of u plus c. And so in all we get negative natural log of cosecant of x plus tangent of x plus c. Yes, Keenan, I'm going to continue until 102 integrals are done. 28. The integral of the square root of x squared plus 4x plus 13 dx. We'll just use difference of squares again. You know, the same old thing. Sorry, not difference of squares. Completing the squares. So the integral of square root of x plus 2 squared plus 9 dx. So now the trick of this is that we will use another trig sub. So we'll let x equal to we'll x equal to about 3 tangent of theta minus 2. So why do we do this? We did this because when we substitute this into x, the -2 and the -2 up here and the +2 will cancel out. And so we'll be just left with 3 tangent of theta quantity squared. And then we square that, we'll get 9 tangent squareds of theta. And so we want the coefficient of tangent squared to equal the coefficient of 9. And so since 3 is the square root, since 9 is the square of 3, that's why we chose 3. So this is equal to, we take the derivative of this, dx is equal to 3 secant squared of theta d theta. Okay, so we get the integral of 3 secant squared of theta times the square root of 9 tangent squared of theta plus 9 d theta. This is equal to square root of 9 times tangent squared of theta plus 1. And so we know tangent squared of theta plus 1 is equal to secant squared of theta. And so we actually get square root of 9 secant squared of theta, which is equal to 3 secant squared. So 3 secant of theta. And so this is equal to integral of 9 secant cubed of theta d theta. We already solved secant cubed. We don't have to do that again. I don't want to do that again. Where is it? Here. And so we know that this is going to be 9 halves ln of secant theta plus tangent theta plus 9 halves tangent theta secant theta plus c. I guess refer back a little bit if you want to see how we got that. And then, okay, and so we know that theta is equal to inverse tangent of x plus 2 quantity over 3. And so finally, we get that this is equal to 9 halves natural log of, oh boy, secant of inverse tangent of x plus 2 over 3 plus, now we could do tangent of inverse tangent, but that's just, why would we do that? So that's just x plus 2 over 3 plus 9 halves times x plus 2 over 3 times secant of inverse tangent of x plus 2 over 3. Jeez. Plus c. So this is actually seems to be unnecessarily long. Truly. Okay. Next one. Question 29. The integral of e to the 2x cosine of x dx. We've done this problem a few times in BC. What we do is we'll do tabular. We'll just do tabular. I don't really want to do integration by parts, the normal kind, a whole bunch of times, so we'll just do tabular. It doesn't really matter which one we choose. They're kind of both the same. So e to the 2x cosine of x. 2 e to the 2x sine of x negative cosine of x 4 e to the 2x. Okay, that's all we really need to go to, because we can kind of stop there. Okay, so blah 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 plus minus plus is equal to, well, first we'll denote this as equal to, as equaling s. We'll let this all equal s. Equal to s. And so we know that s is equal to e to the 2x sine of x plus 2e to the 2x cosine of x minus the integral of 4e to the 2x cosine of x dx. Well, isn't this just equal to 4s? And so if we add 4s to both sides, we get that 5s is equal to e to the 2x sine of x plus 2e to the 2x cosine of x. And so we can divide 5 by both sides to get the s, which is our answer, is equal to 1/5 e to the 2x sine of x plus 2/5 e to the 2x cosine of x. And we are done. Yep, we're done with this one. Question 30. Integral from 3 to 5 of x minus 30 to the 9th power dx. Those ones just, I guess, a palate cleanser. U is equal to x minus 3, du is equal to dx. And so, this integral, we have to remember to substitute 3 and 5 into u equals x minus 3. Otherwise, you will not get the correct answer. Is equal, so we get the integral from 0 to 2 of u to the 9th power du. Of course, if we wanted to, you keep the bounds, but remember, you have to substitute it back into the x world, which is just, I find that a little just harder. And so it's equal to 1/10 u to the 10th from 0 to 2. So really this is just equal to 1/10 to the 10th times 2 to the 10th, which I will not simplify because that is not a pretty number. Let's go to the next question, 31. The integral of 1 over square root of x minus x to the 3/2 dx. Okay. Clash of Clans? I think I have one, I just never use it ever, so yeah. No, the username is not Harry. So we'll do something similar to a question before. So we're actually going to take an x out of it. So here's what we'll do. So this is equal to integral of, we can rewrite this as x times 1 minus x to the 1/2 dx. And so we can kind of just take out the x in front. And so we get the integral of 1 over square root of x times square root of 1 minus x to the 1/2 power dx. And so now we're going to let u equal 1 minus x to the 1/2 power, which means du is equal to negative 1/2 times x to the 1/2 power dx. We have an x to the 1/2 power on the bottom, on the denominator. And so that actually does cancel out pretty nicely. So it's equal to integral of negative 2 over square root of u du. And then so this is equal to the integral of negative 2 u to the negative 1/2 du, which is going to be equal to negative for u to the 1 half power plus c. And so we just have to substitute u back in, and we get negative 4 times 1 minus x to the 1 half power, all to the 1 half power plus c. Um, 32. So this is the integral of 1 over square root of x minus x squared dx. Okay, I see how to do this one. So we're going to complete the square again. So 1 over square root of... So the way in which we're going to complete the square is going to be kind of weird. So yeah, so we know it's going to be minus x minus 1 half squared. Because what that would do is when we square this, we get x squared. So positive x squared times minus, that's negative x squared, which is good. That's what we have here. And then we'll have minus x. Minus x times negative is going to be plus x, which we have here. And then, so now we have to find out which value goes, what constant would go before all of this stuff to make it still equivalent to the square root of x minus x squared. So we look at the 1 half squared. 1 half squared, that's 1/4, minus 1/4. So we have a negative 1/4, but we want to get the equal. So we'll actually put a 1/4 here. Because we have minus 1/4 and we plus 1/4, they cancel out to get a 0. And we have a 0 on the left side. So everything's good. We have it in order. We'll use a u sub for clarity. U is equal to negative x minus 1 half. It means du is equal to dx. And so we have this integral of 1 over square root of 1 half squared minus u squared du. Does this resemble anything? It should. It resembles the inverse sine. It resembles inverse sine a lot. So yeah, so we can just kind of use the inverse trig rules to solve these. And so we get, using the inverse sine rule, this is equal to inverse sine of u over 1 half. So yeah, plus c, which is equal to inverse sine of x minus 1 half times 2. Since when you divide by 1 half, you're multiplying by 2, right? Plus c, which for, just to make it look nicer, we're going to write it as 2x minus 1 plus c. Okay. Next one. No, 33. The integral of e to the 2 natural log of x dx. So let's see here. Okay, let's rewrite this. We'll rewrite this as e to the ln of x squared dx, because we can do this, right? Because by exponent properties. When we raise an exponent to another exponent, we're really multiplying them together. And so e to the ln of x, we actually simplify that. That's just equal to x. So x squared dx. Yes, Nikhil, Poco is very OP. Anyway, and so the integral of x squared, that's pretty easy. That's just 1/3 x cubed plus c. And that is our final answer here. Okay, 34. We are 1/3 of the way through. We're really not on track, time-wise. This might go until like 6 o'clock. Am I doing the math right? I don't know. 34. The integral of ln of x over square root of x dx. Huh. Okay, we'll let u equal square root of x, which means du is equal to 1 over 2u dx. So this is equal to the integral of 2u ln of u squared, because, you know, square root of x squared is equal to x over u. The u's cancel out, and so we're just left with the integral of 2 lns of u squared du. However, because of lateral log properties, we can rewrite this as the integral of 4 natural logs of u du. And if you don't have this memorized, we could just use integration by parts to find that this is equal to 4u ln of u minus 4 ln of u plus c. Wait, that's not true. I'm sorry. Let me erase all this. Is equal to 4u ln of u minus 4u plus c. What? Hi, Srithan. Why are people... something going on? Okay, whatever. Okay. And so we substitute u back in, and we get it's equal to 4 square roots of x ln of square root of x minus 4 square roots of x plus c, and we are done. The integral of e to the x 1 over e to the x plus e to the negative x dx. So let's multiply the top and bottom by e to the x, and so we get e to the x over so e to the x times e to the x, just e to the 2x, and e to the x times e to the negative x, that's just 1. And so next we'll let u equal to e to the x, since there's an e to the x on the top. I mean, it's worth a shot, right? dz to e to the x still times dx, and so we get that's equal to the integral of the top gets canceled out because there's an e to the x on top. On the bottom we have an e to the x 2x. Well, that's the same thing as e to the x quantity squared, and so really we just have u squared plus 1. And so this is pretty familiar, just inverse tangent of u plus c, or in other words, inverse tangent of e to the x plus c. 36. The integral of just log base 2 of x dx. I mean, that's interesting. So what we'll do here is I guess we'll use integration by parts. So d will be equal to log base 2 of x. What will I be equal to? Well, there's not really a whole lot left. There's really just a 1, so I will be equal to 1. The derivative of log base 2 of x, if you recall, that is equal to, that's 1 over x times ln of 2. And then on the integration side, we just have x. Plus minus, and so this is equal to x log base 2 of x minus the integral of 1 over ln 2 of x times dx. And so this is equal to x log base 2 of x minus 1 over ln of 2 times x plus c. That is our final answer for 36. Onward we go. 37. The integral of x cubed times sine of 2x dx. Okay. Oh no, this is just going to be one huge integration by parts thing. So, as we'll let d equal x cubed since that's linear, and then, sorry, it's algebraic, and then we'll let I be sine of 2x. So, down the d chain, get 3x squared, and then 6x, and then 6, and then 0. Down the I chain, we get negative 2 cosines of 2x. Now, negative 1/2 cosine of 2x. And then we get negative 1/4 sine of 2x. And then 1/8 cosine of 2x. And then finally, 1/16 sine of 2x. Plus minus, plus minus. Done, 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 done. Let's put this all together. Okay, so we get minus 1/2 x cubed cosine of 2x plus 3/4 x squared sine of 2x plus 3/4 cosine of 2x minus 3/8 sine of 2x plus c. Who's Keenan get on Discord? What? Someone actually named themselves that? Oh, that's 37. We were on 37. Well, actually, now we're on 38. Hey, 5.5 hours. The integral of x squared of the cube root of 1 plus x cubed dx. This is a fairly straightforward u sum. Just let u equal to 1 plus x cubed, which means du is equal to 3x squared dx. This is the integral of 1/3, well, cube root of u du. And so, This is 1/3 times the integral of u to the 1/3 du. Oof. Okay, and so this would be times 1/3 times, well, 3/4 u to the 4/3 power plus c. The 1/3 and 3 on the top cancel out, so we actually just left with 1/4. And so we are at, let's see here, is equal to 1/4 1 plus x cubed to the 4/3 power plus c. We're done with that. Next. $39. Yeah, they're done. The integral of, oh, this one's a weird one. 1 over x squared plus 4 quantity squared dx. Well, I don't think partial fractions would really work on this one. I mean, we could certainly try. Okay. I don't think that would work. What if we try dividing them, or trying to factor out like an x or something? What would that give us? That would give us 1 over x plus 4 over x. It's kind of weird. Times x squared. No, that wouldn't really work because what is Caligula's pony? Okay. Yeah, that wouldn't really be too successful because if we try using u sub on x plus 4 over x, we would get 1 minus 4 over x squared. So that 1 there kind of, that 1 there doesn't really help us at all. In fact, it's kind of actively bad. So, what else can we do? I don't think you can factor it in any other way, really. That wouldn't really work. I guess we could try. I'm trying to increase my parts. I don't think it really gets anywhere though. We could try trig sub. I think that's worth a shot. So let's let x equal to 2 tangents of theta, which means dx is equal to 2 secant squared of theta, d theta. typically you would use trig sub whenever you have like an x squared plus something, or an x squared minus something, or maybe like a 1 minus x squared. Just wherever you would find the x squared is typically where you would use trig sub. So it might work here. So we have the integral of so we substitute this back in. We get 2 secant squared of theta on top divided by well, this would be 4 tangent squared of theta plus 4 squared, which is, I mean, this is 4 times tangent squared plus 1 squared. Tangent squared of 1 is going to be secant, so this actually turns into 16 secant to the 4th power of theta, really. And so, okay, so this is equal to the integral of 2 secant squared of theta over 16 secant to the 4th power of theta, d theta. And so this becomes integral of 1/8 cosine squared of theta, d theta. What? I'm sorry they could do that. Anyway, so yeah, so we remember that cosine of cosine squared of theta. Huh? Oh, whatever. Cosine squared of theta is equal to 1 plus cosine of 2 theta over 2. Okay, so this is equal to the integral of 1 over 16 plus 1 over 16 cosine of 2 theta then, d theta, which finally is equal to 1 over 16 theta plus 1 over 32 sines of 2 theta plus c. Substitute theta back in. Recall that theta is equal to inverse tangent of x over 2. And finally, our answer is 1 over 16, inverse tangent of x over 2, plus 1 over 32 sines of 2, oh geez, 2 inverse tangents of x over 2, god, plus c. Oh yeah, this answer is kind of bad. But I mean, that's a lot of integrals, so $40. Wow, can't believe we are 2/5 of the way through this. We're almost halfway. That's like, oh, so we've only been doing this for 2 hours, so I guess we're like on track for 5 hours actually. That's nice. The integral from 1 to 2 of the square root of x squared minus 1 dx. Oh, cool. I'm beating Blackpenredpen right now. That's amazing. I really see no other way to do this other than trig sub. So I think the appropriate one here would be secant, because of the minus 1. And so we'll let x equal to secant of theta dx is equal to secant theta tangent theta d theta. Oof. Okay. And so it's the integral of When we change the bounds, remember to use the fact that theta, we have to use theta is equal to, not x is equal to, so theta is equal to inverse secant of x. It's kind of a weird one. Okay, so yeah. So the inverse secant of 1 is equal to the, well, is actually, inverse secant is actually equal to 1 over inverse cosine. And so we can just actually find out, I'm sorry. Wait. Is that what it is? Wait, no, I don't think that's what it is. Well, anyway, so I'm sorry, it's inverse cosine of 1 over x. And so to find this inverse secant of 1, so that's be the inverse cosine of 1 over 1, so inverse cosine of 1, which we know to just be 0. And then find the inverse secant of 2, that's the inverse cosine of 1 over 2. So the inverse cosine of 1/2, that would be pi over 3. So those are our bounds, and then we substitute this in, we get secant theta, tangent theta, times, well, okay, so when we substitute secant theta in for x, we get secant squared minus 1. That's equal to tangent squared, and so the square root of tangent squared, that's just equal to tangent of theta. And yeah, so d theta. And so we have what we really have is secant theta times tangent squared theta. What? Oh, it's a tricky one then. So we've had the conundrum of secant times tangent squared theta before, and that was back in the secant cubed theta one, which is, let me see how far back that was. Yeah, it was a while back. Um, all right. So here's what we know. If we look back into question 24, the one about secant cubed theta, here we have the following. We know the following. Okay, so we know that the integral of secant cubed of x dx is equal to the natural log of secant of x plus tangent of x plus the integral of secant of x tangent squared of x dx. We also know that this same thing, so the same integral secant cubed of x dx is equal to 1/2 natural log of secant x plus tangent x plus 1/2 tangent x secant x plus c. So what we can do is we can actually set these equal to each other. We can set these equal to each other. And so, and if we set these equal to each other, we can isolate the integral of secant x tangent squared of x, and so we get that the integral of secant x tangent squared of x dx is equal to, in all, that would be 1/2 tangent x secant x minus 1/2 natural log of secant x plus tangent x plus c. And so, well, now we have to remember this is a definite integral. And so we have to evaluate this from pi over 3 to 0. And so really, we have to, so here, we evaluate from 0 to pi over 3. And so let's proceed. What is the value of this when we plug in pi over 3? Well, 1/2 times square root of 3 times 2 minus 1/2 times the natural log of 2 plus square root of 3. And it's minus 1/2 times 0 times 1 minus 1/2 times the natural log of 1 plus 0. And so this is just equal to, well, if you look on the right side, 1/2 times 0 times 1, that's 0. And then 1/2 times natural log of just 1, that's still 0. So really we're only looking at this side. So we have square root of 3 minus 1/2 natural logs of 2 plus square root of 3 y. Hey, we have some fun ones now. 41. The integral of hyperbolic sine. This is just cosine. This is just cosine, hyperbolic cosine plus c. And so this, okay, so hyperbolic sine is really not something they teach a lot at all. So here's what hyperbolic sine and hyperbolic cosine really are. So hyperbolic sine is really e to the x minus e to the negative x all over 2. And then hyperbolic cosine is equal to e to the x plus e to the negative x all over 2. And so if we take the integral of sine of hx and we have it in exponential form, as I'll call it, then we just get, we get e to the x plus e to the negative x over 2, which just happens to be hyperbolic cosine. So we're done with that. Okay, let's move on. Oh, shoot. Okay, my phone is running out of battery. What do I do now? Oh, sorry, never mind. I have a charging port right next to the spot I'm at. Sorry, I'm going to shift the camera a little bit. It's back to normal. Yes. And we continue. The integral of x squared I think I did that at some point. The integral of x squared. The integral of x squared is 1/3 x cubed plus c. There you go. What question were we even on? We were on question 42. I use my pencil. The integral of sine h square root of x dx. Okay. Let's find out some more identities of let's find out a few more identities of these hyperbolic whatevers. So there is a power reducing formula as well for of hyperbolic sine. So a lot of the hyperbolic trig functions are actually very similar to the regular trig functions, hence why they're called hyperbolic, like sine, hyperbolic, cosine. And so we just have to use some of the same ones. Now which ones will we use? So the one we'll use here for sine of h is that hyperbolic cosine of 2x is equal to 1 plus hyperbolic sine squared. Sorry, 2 hyperbolic sine squared of just x. So we can rearrange this, as normal, and we get that hyperbolic sine h squared of x is equal to hyperbolic cosine of 2x minus 1 quantity over 2. Okay. So this means that this is equal to the integral of 1/2 hyperbolic cosine of 2x minus 1/2 dx. Cool. And so the integral of hyperbolic cosine is hyperbolic sine, positive hyperbolic sine still. So here's what we'll do. This is just equal to 1/4 hyperbolic sine of h of 2x minus 1/2 x plus c. That is our answer for this one. Then we can move on. 43. Okay, so 43. This one's, again, just really similar. Hyperbolic sine of h cubed x dx, the integral of that. And so what we'll do for this one's, just like if this was sine cubed, we will use some identities. So this is equal to the integral of sine of h of x times 1 minus, what is it minus cosine of h? Wait. It should be 1 plus, sorry, inverse hyperbolic sine of x dx. Oof. Okay. And so then we can let u equal to hyperbolic cosine of x. Means du is equal to hyperbolic sine of x dx. What? Anyway, yeah, so we have a hyperbolic sine on the top there. And so this simplifies into the integral of 1 plus u squared du, which is just, u plus 1/3 u cubed plus c. Substituting that back in, we get 1/3 hyperbolic cosine of h cubed of x
plus hyperbolic cosine of x plus c.
And we are done.
.44. The integral of 1 over square root of x squared plus 1 dx.
Yeah, what is that equal to? If I recall correctly, this one's just going to be equal to the inverse hyperbolic sine. Yeah.
So here we go. Inverse hyperbolic sine inverse of x plus c.
Yeah. We can prove this by differentiating. So if we let
Y equal inverse hyperbolic sine of x, hyperbolic sine of y is equal to x. If we do implicit differentiation here, we find that hyperbolic cosine of y dy is equal to dx. And so dy over dx is equal to 1 over hyperbolic cosine of y. And then using that identity, sine squared, hyperbolic sine squared of x plus, minus hyperbolic cosine squared of y of x is equal to 1.
This, we find that the dy over dx is equal to 1 over square root of x squared plus 1, as desired. Here we go.
45. The integral of the natural log of x plus square root of 1 plus x squared dx.
Oh, hello, Akshar. I'm on question 45 now. Ooh. This should just be another trig sub. I'm assuming just another trig sub, actually. Based on what these problems have been doing, I'm assuming it wants me to do hyperbolic trig sub, which I will try to avoid if at all possible.
Anyway, let's let x equal to tangent of theta, which means dx is equal to secant squared of theta d theta. This is equal to the integral of the natural log, of secant squared of theta times the natural log of tangent theta plus secant theta d theta.
This is interesting. Okay. I'm trying integration by parts.
There's something interesting about tangent theta plus secant theta if we let that be the derivative one. So ln of tangent plus secant, I don't really have a lot of room to write it on. Should give myself more room, that's fine. Secant theta on the right side. The integral of secant theta is just tangent theta. And the derivative of natural log of tangent plus secant is equal to that's just secant of theta. And so plus minus theta is equal to tangent theta times the natural log of tangent theta plus secant theta minus the integral of secant theta tangent theta d theta. Oof. Okay, and we know what the integral of secant theta tangent theta is. That's just secant theta. So finally, we have the t is equal to tangent theta times the natural log of tangent theta plus secant theta minus secant theta plus c. Oof. And then we substitute, then we know that theta is equal to inverse tangent of x, and so we have to substitute that in. And so finally it's equal to x times the natural log of x plus secant of inverse tangent of x minus secant of the inverse tangent of x plus c. Oof. 46. The integral of the hyperbolic tangent of x dx. This is tangent. Hyperbolic tangent is like the same thing as regular tangent. It's equal to the integral of the hyperbolic sine of x over hyperbolic cosine of x dx. And so let's just let u equal to hyperbolic cosine of x. It means du is equal to hyperbolic sine of x dx. So this is equal to the integral of 1 over u du, which is equal to natural log of u plus c, or natural log of hyperbolic cosine of x plus c. I had just finished 46 for Shab, so now I'm doing 47. You guys still hear me, right? Hope so. $47. So we have the integral of just hyperbolic secant of x dx. So this is the exact same thing as in, so this is of course 1 over cosine. However, we don't really need that. So we do something pretty similar. So we'll do something pretty similar to how we derived the integral for regular secant. We'll multiply the top and bottom by hyperbolic secant plus hyperbolic tangent. And so that's equal to the integral of hyperbolic secant squared of x plus hyperbolic secant of x, hyperbolic tangent of x, all over hyperbolic secant of x plus hyperbolic tangent of x dx. Yes, hyperbolic secant. It's like the regular secant, but for hyperbolas. Okay, so some things we have to lay down for a second is that the derivative of hyperbolic tangent is equal to hyperbolic secant squared. No surprises there. And the derivative of hyperbolic secant is equal to negative hyperbolic secant x times hyperbolic tangent of x. So it's slightly different, kind of the same. Wait, is that? Oh, I'm sorry. That puts a few wrinkles. than what we're gonna do, unfortunately. Hmm. Hmm. Okay. Well. Oh, so yeah. This. I don't think this will really. I don't think this method will really apply then, if that's the case. Um. Kind of should have thought this through a little bit more. Who's Tony Montana? Well. Hmm. Okay. What? I guess I'll try the exponential form. Maybe that'll. If typically if the trig form doesn't work, the exponential form will. So. So this is. So we know that hyperbolic cosine is equal to e to the x plus e to the negative x, quantity over 2. So the inverse hyperbolic secant would be 2 over e to the x plus e to the negative x dx. Actually, we already solved this. Yeah, this is actually not that bad. And so this is equal to the integral of 2 e to the x times over 2 to the e to the 2x plus 1 dx. We have already solved this. This is equal to 2 times the inverse tangent of e to the x, I believe. Yeah, plus c. And so that is our final answer. What? What is it? What are you guys doing in chat? Well, anyway, yes, that will be our answer, I think. Yeah, I think that's our answer. It's kind of weird that it's not in any trig function. But whatever. So next question, 48. I'm not going to write it as arctan. Take up too much room to write. The integral of the inverse tangent of x dx. Oh, we're almost done with the hyperbolic stuff. Okay, so first things first, we have to find out what the heck the derivative of inverse hyperbolic tangent is. So let y equal inverse hyperbolic tangent of x. It means the hyperbolic tangent of y is equal to x, which means that hyperbolic secant squared of y dy is equal to dx. means dy over dx is equal to 1 over hyperbolic secant of square root of y. Means dy over dx is equal to wait, one. Wait, so it's cosine squared minus sine squared. It should be over 1 over 1 minus x squared, I think the answer is, dy over dx. Okay, so with that noted, we can start using integration by parts. The derivative will set as inverse hyperbolic tangent, and the integration will set as 1. The derivative of this would be 1 over 1 minus x squared. The integral would be, just be x. Plus minus, so you have this equal to x times the inverse hyperbolic tangent of x minus integral of x over 1 minus x squared dx. Green bean is not a chat mod. That the crown does not mean chat mod. If he was a chat mod, I would really be opposed to that. So, yeah. In fact, let me should I time out? Should I time him out? In fact, I should. Guys, do you think I should time out whatever his name is? I don't even know what his name is. Should I time out Green Bean? Okay, I have 1 yes, 1 no. Okay, well, we have not come to a decision yet, so I'm just gonna not do it then. You're safe for now, Green Bean. Anyway, the integral of x over 1 minus x squared, that's pretty easy to do. And so that would just be 1/2 times the natural log of 1 minus x squared plus c. I just finished 48 actually. I think I'm 49 now. Next one, 49. I think this is the last of all the hyperbolic stuff. After this, we'll be going back to regular trig. Integral of tan inverse of x dx. Ow. Okay, this one is this one's not gonna be pretty because I know the square root of tangent x is already kind of it's already kind of not good. So I think the hyperbolic tangent of it's not gonna be great. What if I just let the entire thing equal u? So we'll let u equal literally all of it. So the square root of hyperbolic tangent would mean du is equal to On top is the have on top be the derivative hyperbolic tangent. So hyperbolic secant squared of x divided by 2u dx. Okay. So we know that so we know that a hyperbolic secant of x hyperbolic secant squared of x is equal to 1 minus hyperbolic tangent squared of x. And so if we fourth root both sides, and then if we do 1 minus, so 1 minus u to the fourth power is going to be equal to 1 minus hyperbolic tangent squared of x, which means it's also going to be equal to hyperbolic secant squared of x. And so really du is equal to 1 minus u to the fourth power over 2u dx. Substituting all of that back in, 6 messages were deleted by a moderator. Jeez. What happened? Okay, anyway. So this is equal to the integral of 2u squared over 1 minus u to the fourth du. Oh boy. Are you guys ready for some awesome are you guys ready for some awesome partial fractions? So it's going to be equal to a over 1 plus u squared ax plus b plus c over 1 plus u plus d over 1 minus u du. Partial derivative? I'm not doing a partial derivative, I'm doing a partial fraction. Oh, this is gonna suck. Okay. So 2u squared is equal to, a times u minus u cubed plus b times 1 minus u squared plus c times 1 minus u plus u squared minus u cubed plus d times 1 plus u squared plus u cubed. Cool. 0 is equal to b plus c plus d. 0 is equal to a minus c plus d. 2 is equal to negative b plus c plus d. And 0 is equal to minus a minus c plus d. Why? Okay. So b is equal to negative 1. A is equal to 0. And so that means we're left with 1 is equal to C plus D. And then 0 is equal to D minus C. And so C and D are both equal to 1/2. Okay. And so what are we left with now? The integral of -1 over 1 plus u squared plus 1/2 over 1 plus u plus 1/2 over 1 minus u, people. Okay, du. Okay, we're in the home stretch, people. Negative inverse tangent of u plus 1/2 natural log of 1 plus u minus 1/2 natural log of 1 minus u plus c. Oh, okay. What even was u? Square root of... Ugh. I'll just... You guys can just look at what I'm writing at now, because, like, I don't... This is kind of not fair to humanity. Good enough. I'm done. I'm done. $50. 0.5 of the floor x dx. Okay, so if we just draw this, from 0 to 1, it's going to be like down here. From 1 to 2, it's going to be like up here, and then like up here, and like up here, and then like finally it's just gonna be like up here. And so we can just kind of, whoa, that's a lot of pog champs. Okay. Okay, and so we can just kind of find the area underneath one of these. So the area under here is 1, and then area under here is 2, and then 3, and then 4. And so this is just 1 plus 2 plus 3 plus 4, which is 10. Amazing, isn't it? 51. The integral, oh my god, why? Secant to the 6th power? Okay, well this is equal to the integral of secant squared of x times 1 plus tangent squared of x squared dx will let u equal tangent of x, which means du is equal to secant squared of x dx. So we have integral of 1 plus u squared of du, integral of 1 plus 2u squared plus u to the 4th du is equal to u plus 2/3 u cubed plus 1/5 u to the 5th plus c, which is equal to 1/5 tangent to the 5th of x plus 2/3 tangent cubed x plus tangent x plus c. Why? Okay, I'm going to go use the restroom for a minute or something or whatever, because this is I drank a lot of water. So I'll be back. Hello. Did you guys miss me? We're about to do an easy one. 52. The integral of 1 over 5x minus 2 to the 4th power dx. Okay, so this is pretty simple. We got u equal 5x minus 2, u is equal to 5 dx. So it's the integral of 1/5 over u to the 4th power, right? Dx. Cool, amazing. So this is just equal to 1/5 times negative 1/3 u to the negative 1/3 plus c. Wait, no, sorry, u to the negative 3. There we go. Okay, and so this is equal to negative 1 over 15 of 5x minus 2 to the negative 3rd plus c. We're done. I'm not a whole lot to say about that one. 53. The integral of the natural log of 1 plus x squared dx. This one seems like a basic trig sub, I guess. Well, not basic, but it seems like trig sub would work on this one, so I don't know. Let's try it. Let's let u equal tangent of x. Let's let x equal tangent of theta, which means dx is equal to secant squared of theta d theta. So, we are left with the integral of secant squared of theta. That's the natural log of secant squared of theta d theta, because 1 plus tangent squared is equal to secant squared. So, what do we do from here? We, Okay, so we could probably pull out the 2 from the secant squared because it's a natural log. Okay, so this is equal to 2 times the integral of secant squared of theta, natural log of just secant theta. This one seems kind of hard to crack. Maybe we could use integration by parts. Yes, I'm hunched over on the ground. This is my floor. So, I mean, we know we can't really integrate ln of secant of theta, so we're probably going to use that to differentiate it, right? We know that this is actually just, well, this is just tangent. The derivative of this is just tangent theta. And then the integral of secant squared of theta, that's also tangent of theta. So, wait, so we can just do plus minus and then, yeah, so this is just equal to 2 tangent theta ln of secant theta minus the integral of tangent squared of theta d theta. We know that tangent squared of theta is equal to secant squared of theta minus 1. So really this is equal to 2 tangent theta ln of secant of theta minus secant squared theta minus 1, which we can integrate to get 2 tangent... Wait, sorry, this is all times 2. Sorry. theta times ln of secant theta minus 2 tangent theta plus 2 theta plus c. Okay, and then finally we just substitute everything back in. So we get 2 equal to 2x natural log of secant of inverse tangent of x minus 2x plus 2 inverse tangents of x plus c.
And we are done with this one.
$54. Oh no. The integral of 1 over x to the 4th plus x dx. There has to be a better way. There.
Okay, so we could do partial fractions, right? Instead of partial fractions, we are going to do the following. We are going to we are going to factor out an x cubed. Sorry, an x to the 4th. So here's what we're going to do. We're going to do integral of 1 over x to the 4th times 1 plus 1 over x cubed. Isn't that nice? And then we let u equal to 1 plus 1 over x cubed to get du is equal to negative 3 over x to the 4th dx. And what do you know? We have an x to the 4th in the denominator.
And so yeah, this actually is way better than what we could have hoped. So we'll get integral of negative 1/3 of just u. So negative 1/3 natural log of u plus c, or in other words, negative 1/3 natural logs of 1 plus 1 over x cubed plus c. $55. The integral of 1 minus tangent of x over 1 plus tangent of x dx. So this is equal to integral of 1 minus sine of x over cosine of x over 1 plus sine of x over cosine of x dx. So we can multiply the top and the bottom by sine of x, by cosine of x. And so we can get integral of cosine of x minus sine of x over cosine of x plus sine of x dx. So this is actually really nice because we can just let u equal to cosine of x plus sine of x, and then du would be equal to cosine of x minus sine of x. Oh wait, what do we have on top? And so really this is just equal to the integral of 1 over u du. which is the natural log of u, plus c. And so we have the natural log of cosine of x plus sine of x plus c. How about that? 56. The integral of x secant of x tangent of x dx. Integration by parts is probably going to be the best way to do this one. I don't really see many other ways to do this one. So d will be x, of course, which will turn to 1, and then 0. Integral will be secant of x tangent of x. The integral of this is just secant of x, and then the integral of secant of x, as we know, is the natural log of secant of x plus tangent x. And so plus minus, and we get x secant of x minus the natural log of secant of x plus tangent of x plus c. Next one, 57. The integral of inverse secant of x dx. We're going to use integration by parts again, as you would typically do on inverse functions. We're going to be differentiating secant of x, secant inverse of x, and then integrating regular 1. The derivative of this is equal to 1 over, I think it was x square root of, is it x squared minus 1? I think it was x squared minus 1. Yeah. And so then we integrate 1 and we just get x. And what we're left with is plus minus. So it's equal to x inverse secant of x minus the integral of 1 over square root of x squared minus 1 dx. well, the integral of 1 over square root of x squared minus 1. I think isn't that a hyperbolic trig function? Wait, that has to be a hyperbolic trig function. Which one is that? Is it cosine or sine? I think it was cosine? I don't know. So it's equal to x secant inverse of x minus hyperbolic cosine of x plus c. Next question. 58. Integral of 1 minus cosine of x over 1 plus cosine of x dx. What if we take the conjugate? So we multiply the top and bottom by 1 minus cosine of x. We will get 1 minus 2 cosine of x plus cosine squared of x over sine squared of x, because 1 minus cosine squared of x is equal to sine squared of x. And the top is just 1 minus cosine of x quantity squared, but expanded. Yeah, and then so now we can split this up into multiple fractions. So we get cosecant squared of x minus 2. We've already done this, haven't we? Cosecant x, cotangent x, plus cotangent squared x dx. This is equal to, using some trig identities, cosecant squared of x minus 2 cosecant x cotangent x plus cosecant squared x minus 1 dx. So this is equal to, now we can combine the cosecant squareds of x's together to get 2 minus 2 cotangent x plus 2 cosecant x minus x dx. Wait, why not dx? Plus c. Integral of x squared times the square root of x plus 4 u is equal to x plus 4 means du is equal to dx, and then of course x is equal to u minus 4, and so it's equal to u minus 4 squared times the square root of u. Whew. Integral of u to the 5 halves minus 8 u to the 3 halves plus 16 u to the 1 half. And so in all, we get 2/7 u to the 7 halves minus 16 over 5 u to the 5 halves plus 32 over 3 u to the 3 halves plus c. And this is equal to 2 over 7 x plus 4 7 halves minus 16 over 5 x plus 4 to the 5 halves plus 32 over 3 x plus 4 to the 3 halves plus c. Next one is 60. The integral from -1 to 1 of square root of 4 minus x squared dx. This is just a circle. This is a circle. Wait. Okay, yeah. So if we let y equal square root of 4 minus x squared, we get that y squared is equal to 4 minus x squared. Or in other words, x squared plus y squared is equal to 4, which is a circle with radius 2. And so we just draw this as like something like that. However, it's from -1 to 1, so that's like somewhere here and then that. Unfortunately, that's not easy to do at all. So we're going to use some trick sub. Let's let x equal to 2 times sine of theta, which means dx is equal to 2 cosine of theta d theta. And so we get this equal to the integral from negative pi over 6 to pi over 6. And then this becomes 2 cosine of theta times another cosine of theta times another times another theta. So as we established before, we use the power reducing formula. I won't repeat that again. And that's, so 4 cosine squared of theta, and that's equal to that's equal to 2 plus 2 cosine of 2 theta d theta. No, so it's equal to 2 theta plus sine of 2 theta evaluated from negative pi over 6 to pi over 6. So that's pi over 3 plus sine of pi over 3 minus negative pi over 3 minus plus sine of negative pi over 3, which is equal to 2 pi over 3 plus 2 square roots of 3. I think. Okay. Wait. I'm sorry, just time plus 1 square root of 3. Okay, we're done with this. 60. The integral of the square root of x squared plus 4x dx. We'll complete the square. So the integral of square root of x plus 2 squared minus 4 and so we'll let x plus 2 equal 2 secants of theta, which means dx is equal to 2 secant theta tangent theta d theta. And then we can kind of insert all of this back in. If we insert this back in, we get 2 secant theta times tangent theta times square root of 4 secant squared theta minus 4 d theta, which that would be equal to 2 times tangent theta. The integral of 2 secant theta tangent square root of theta d theta. And we have done this particular one a few times before. Let me see where it is. Back to question 40, I think. Yep. Okay. And so because of question 40, we know that this actually happens to be equal to it's actually equal to tangent x secant of x minus 1/2 natural log of secant of x plus tangent of x plus c. Wait, sorry, no 1/2 here? Yeah. Um, um, Okay, I guess I'll just take that as correct then. Yeah, okay, next question. Oh wait, sorry, I'm silly, I never substituted, I never substitute x back in. Okay, and so this, we know that, I'm sorry. We know that theta is equal to inverse secant of x plus 2 over 2. And so that means that this is actually equal to tangent of inverse secant of x plus 2 over 2 times x plus 2 over 2 minus natural log of x plus 2 over 2 plus tangent of inverse secant of x plus 2 over 2 plus c. So now we move on to 62. So it's the integral of x squared e to the x cubed dx. Pretty easy, you just let u equal x cubed, du is equal to 3x squared dx. So this is actually equal to 1/3 times the integral of e to the u du. So 1/3 e to the u plus c, or 1/3 e to the x cubed plus c. 63. Integral of x cubed e to the x squared dx. We'll do something similar. We'll let u equal to x squared, and then du is equal to 2x dx. And so this becomes 1/2 times the integral of. So one of the x's out of the x cubed gets canceled out, but there's still an x squared left, so we can let that equal u. And so e to the u du. By integration by parts, we get that this is the same thing as, see here, is equal to 1/2 u e to the u minus 1/2 e to the u plus c. So 1/2 x squared e to the x squared minus 1/2 e to the x squared plus c. Whew. So we have the integral of tangent x times natural log of cosine x now for 64. What we notice is that the natural log of cosine x is actually pretty close to, if we take the derivative, that's pretty close to tangent x. So let's actually see how close it is. So u is equal to ln of cosine of x. So du is equal to, well, negative sine of x over cosine of x dx, which is equal to negative tangent x dx. So actually it's like exactly it, just the negative of it. And so it's equal to the integral of negative u du, so negative 1/2 u squared plus c, or negative 1/2 ln of cosine x squared plus c. Not too bad. 65. Okay, 65. Yes, thank you, Eli. 3.5 hours straight. Oh my god. We are 2/3 of the way through. 2/3. We still have another third to go. 65. The integral of 1 over x cubed minus 4x squared. If this isn't a partial fractions, I don't know what the heck this is, because this is exactly it. So, I mean, this would be a over x minus 4. Okay, and since we have an x squared and an x, we have to actually make them their own terms. So this is a over x minus 4 plus b over x plus cx plus d over x squared dx. Let's get doing this. 1 is equal to ax squared plus b x cubed minus 4x squared plus c x cubed minus 4x squared plus d x squared minus 4x. Okay. Let's cover this one by one now. So 0 for the x cubed is equal to b plus c. 0 for the x squared is equal to a minus 4b. Wait. I'm sorry, we don't even need a c. My apologies. I was mistaken. Okay, yeah. So yeah, okay. So actually, hmm. Well, okay. So 0 is equal to b, oddly enough. And then 0 is equal to a minus 4b plus d. That's the x squared. It's for the x. That's just equal to minus 4d. Wait, are any of these just Wait a second. Hmm. Hmm. None of these. Um. Okay. This one's weird. Can this even be partial fractioned? I would imagine yes. Okay, what if I try? B over x, maybe a over x minus 4 plus b over x squared is like, oh, well, no, bx plus c. Because then, I don't know, maybe it would be 1 is equal to ax squared plus bx squared minus 4x plus c x minus 4. I don't know, maybe that's more reasonable. Okay, because then 0 have to be equal to a plus b and then 0 has to equal to negative 4b plus c, and then 1 is equal to negative 4c. I think this works. Okay, then I guess c is equal to negative 1/4, and then b is equal to, and then a is equal to, okay, b is equal to negative 1/16, and then e is equal to 1/16. Is that correct? Oh, because I did the top one wrong. Ah. Okay, I'm silly. Okay. But yeah, this is, yeah, this will be what it would be equal to. I think. Okay, so this is equal to the integral of 1/16 over x minus 4 plus, or rather minus, 1/16 over x minus 1/4 over x squared dx. So then this is not too bad of a partial fraction. This would be 1/16 natural logs of x minus 4 minus natural log, minus 1/16 natural logs of x plus 1/4 x to the negative first power plus c. Okay. That wasn't too bad. I was just being a little bit, I was kind of dumb. 66. The integral of sine of x cosine of 2x dx. Okay, so there are a variety of things we can make cosine of 2x use as the identity. So since there are a variety of things, we are going to, since there's a sine of x already on there, we're going to try to make it, try to turn that into something that's just in terms of cosine of x, so that we can let u equal to cosine of x. So which one would work there? Well, this one would. Sine of x times, or cosine of 2x is equal to 2 cosine squared of x minus 1 dx, and so u is equal to cosine of x. Du is equal to negative sine of x dx. Okay, and so this is equal to the integral of negative 2u squared plus 1 du, which very simply is negative 2/3 u cubed plus u plus c, or minus 2/3 cosine cubed of x plus cosine of x plus c. Next, 67. Take a drink of water. The integral of 2 to the natural log of x dx. This one is simpler than you think, because this is equal to the integral of e to the natural log of 2 to the natural log of x, because e to the natural log of 2 is equal to 2 dx. Okay, so we have that dx, and so we can swap the natural log of x and the natural log of 2. And so this is equal to the integral of e to the natural log of x to the natural log of 2 dx. The natural log and the e cancel out, so we just left with the integral of x to the natural log of 2 dx. What do we do here? Well, we can just use a power rule because it's x to the constant. So this is equal to x to the natural log of 2 plus 1 divided by natural log of 2 plus 1 plus c. Final answer. Okay. Question 68. The integral of the square root of 1 plus cosine of 2x dx. One more to go. I'm at 68. We use another one of the cosine of 2x identities. This time we're going to set this equal to 1 plus well, actually it's the exact same one. Cosine squared 2 times cosine squared of x minus 1 dx. And so this is actually just going to be equal to the integral of square root of 2 times cosine of x. The plus 1 and minus 1 just cancel out. So, now we can just integrate this normally and we get square root of 2 sines of x plus c. Oh, okay. This is what you guys were meaning. Okay, we're at 69 now. Oh boy, 69, of course. The integral of 1 over 1 plus tangent x. Yes. Okay, so the thing is, if we add tangent of x to it, to the top, we get just the top and bottom cancel on, we just get 1. If we subtract tangent x, well, we already solved that, so we can't. So that also produces a value we can integrate. However, is there to be another 1, and so what we can do is we can actually just. So this would actually just be equal to 1/2 times the integral of 1 plus tangent x over 1 plus tangent x plus 1 minus tangent x over 1 plus tangent x dx. The reason this works is because when we combine the two fractions, we get 2 over 1 plus tangent of x. And then when we apply the 1/2, we just get we're back to 1 over 1 plus tangent x. So the statements are equivalent, and so we already integrated both, so we're left with 1/2 x. And then what was that value equal to? We already did this one. Question 55. One half x plus 1/2 times the natural log of cosine of x plus sine of x. Beautiful. I think we have no room for 70. 70. The integral from 1 over e to e of the square root of 1 minus natural log of x squared over x dx. Well, we have an x on the bottom, so what we can do is we can let u equal to natural log of x. So du is equal to 1 over x dx. We can change the bounds. The natural log of e is 1. The natural log of 1 over e is negative 1, because that's just e to the negative first power. And so we're left with square root of 1 minus u squared du. This is a circle. I've already gone over why it's a circle, but it is a circle with radius 1. Looks like that. So since it's a circle, well, since it's a semicircle really, with radius 1, we have 1/2 pi r squared. So when r is equal to 1, we have 1/2 pi times 1 squared. So final answer is 1/2 pi. $71. The integral of 1 over the cube root of x plus 1. Okay, this one's okay, so let's let, well, can we let u equal to, what happens if we let u equal to the third root of x? That means du is equal to 1 over 3 x to the 1, well, 2/3 dx, which is equal to 1 over 3 u squared du. Well, what we get is we get the integral of 3u squared over u plus 1 du. And so we can just use some synthetic division. Find this equal to 3 minus, 3u minus 3u minus 3 plus 3 over u plus 1 du. Right, and so this is equal to 3/2 u squared minus 3u plus 3 natural log of u plus 1 plus c. And so our final answer is 3/2 x to the 2/3 power minus 3x to the 1/3 power plus 3 natural logs of x to the 1/3 power plus 1 plus c. I thought, that wasn't too bad. $72. What is 72? Wait, this is the exact same one. Does it want me to do it in a different way or something? Oh, um, oh, wait, no, they're different. Oops, whoopsie. Okay, yeah, so this is easy then. Just, well, I'll just do it in one step. It's, x plus 1 to the 2/3 power, 3/2. Let's see. Wow, that's misreading. Okay. 73. Integral of sine x plus cosine x quantity squared dx. We can just expand this out. Integral of sine squared x plus cosine squared x. There's a reason I'm putting these two together. Plus 2 sine x cosine x dx. Well, we know that sine of squared of x plus cosine squared of x is just 1, and that 2 sine of x, 2 cosine of x is 2 sine of, it's just sine of 2x. So really, this is just 1 plus sine of 2x. So it's actually pretty easy to integrate. This is equal to x minus 1/2 cosine 2x plus c. And we're done. 73 over with 74. The integral of 2x natural logs of 1 plus x dx. This should be pretty simple. We can just kind of use integration by parts. So we'll let natural log of 1 plus x be the d and the 2x be I. When we integrate, we get x squared, and we differentiate, we get 1 over x plus 1. I don't really want to go any further with this, so we're just going to stop here. So it's equal to x squared natural logs of 1 plus x minus x squared over x plus 1. Oh, the integral of that, sorry. Yeah. Okay, how do we do this? Well, we can just use synthetic division. So really it's just x squared natural log of 1 plus x minus the integral of x minus 1 plus 1 over x plus 1. And so we're left with, so we can just integrate directly now. X squared natural log of 1 plus x minus 1/2 x squared plus x minus natural logs of x plus 1 plus c. Ooh, okay. So what's 75? $75 is the integral of 1 over x times 1 plus sine squared of natural log of x dx. So u is equal to natural log of x, du is equal to 1 over x dx. Yeah, so we have one. We already have an x in the denominator, so that cancels out nicely. So left with the integral of 1 over 1 plus sine squared of x dx.
Huh.
This is interesting. Wait, not x, sorry. These would be u. Mm. What if we added and then subtracted sine squared? Would that do anything? Not really. Um, this one's hard. I don't really like sine squared. So sine squared is 1 minus cosine squared. Does that help at all? If we... Oh. Well, oh. Maybe if we divide by cosine, is that something we can do? I don't know, let's try it. Oh, that looks prettier, I guess. Oh, yes, secant squared on top, you can let u equal tangent x. So du is equal to secant squared of x dx. And then to get secant squared, u squared plus 1 is equal to secant squared of x. Okay, yeah, okay, so it becomes equal to 1 over 1 plus 2u squared du. Okay, so yeah, this would just be equal to, wait, oh yeah, we need to let, oh, it's kind of a mess, isn't it? I guess after this we have to all use, and then this would be a V, and then a U, and then a V, and then a U, and then a V, and then a U, and then a U, and then a V, and then a V. Okay, well, this will let W equal, we'll let U equal square root of 2, or we'll let U equal 1 over square root of 2. Wait, we'll let W equal, which means dW is equal to 1 over square root of 2 dV. And then ooh. V is equal to 1 over square root of 2 W dV is equal to 1 over square root of 2 dW. Okay, yeah, there we go. And so then we can substitute V directly in, and so we get 1 plus W squared, and then times square root of 2. So that's just equal to inverse tangent of square root of 2 inverse tangent of W. So now we have a ton of substitution to go through. So this is square root of 2 inverse tangent of V square root of 2 plus C, which is equal to square root of 2 inverse tangent of oh geez, tangent of U times square root of 2 plus C. Oh, I made a mistake, didn't I? Whoops. There we go. And so that's equal to 1 over square root of 2 inverse tangent of natural log of x square root of 2 plus C. Okay. This one was kind of bad, but we did it still. 76. Integral of square root of 1 minus x over 1 plus x dx. I want to see how I can switch pens. This one's kind of getting a little exhausted. Okay, so we can try splitting into its constituent parts, which is to say, turn this into integral of 1 minus x divided by the square root of 1 plus x dx. Oh, and then we multiply the top and bottom by 1, the square root of 1 minus x. And so we get integral of actual 1 minus x over square root of 1 minus x squared. Okay, cool. And so this is, we split this into two fractions now. So 1 over square root of 1 minus x squared minus x over 1 minus x squared, square root of that, dx. And so for the left part, that's just arc sine. So inverse sine of x. And then for the right one, that's just that would just be a that would be a u sub. So if we let u equal 1 minus x squared, we get du is equal to negative 2x dx. And so we are left with plus 1/2 square root of u du sine inverse of x plus u to the 1/2 power plus c. So finally our answer is the inverse sine of x plus 1 minus x squared to the power of 1/2 plus c. Rish Bob, multiply by conjugate. That is indeed what I did. Thank you. 77, this one looks cool. Integral of x to the x over ln of x dx. That's a lot of x's. No, so we'll do the e to the ln x of trick again. So this will be e to the ln of x to the power of x over ln of x dx. So this time though we'll just combine that together, and so we should get integral of e to the x over ln of x times ln of x. Of course, the ln of x's cancel, and so we're actually just left with e to the x dx, which is obviously just e to the x plus c. Oh, actually, we don't have this paper. Okay. $78. We've gotten quite far. 78. Jeez. Okay. The integral of inverse sine of square root of x dx. That square root of x is not looking really that great, so we're going to try to u sub that thing out. U is equal to square root of x, so du is equal to 1 over 2u dx. And so this is equal to the integral of 2u times the inverse sine of u du. Oh. Oh, okay. So and then from here, it's we should be able to just use integration by parts. We'll let the d be the sine inverse, and then I will integrate 2u. And so here's what we get. We get 1 over square root of 1 minus u squared, and then just regular u squared here. Okay, we'll see. Let's see what we can do with this. And so we have u squared sine inverse of u minus the integral of u squared over square root of 1 minus u squared du. Okay.
This one. This one seems kind of rough. We'll probably get somewhere with this. Is there another easier way though? Let's try trick sub. Okay. So we'll let u. Well, I'm using pencil again. Whoops. We'll let u equal sine of v, which means du is equal to cosine of v dv. Whew, okay. And so this integral becomes cosine of v times sine squared of v divided by this will end up being cosine of v dv. This will cancel out. Hey, and then we're just left with sine squared of v. Okay, we're in the home stretch of this integral. I'll start substituting stuff in here already. And then we're left with the integral of, I'll do 1/2 minus 1/2 cosine of 2v dv. So this becomes minus 1/2 x plus 1/4 sines of 2v. Wait, sorry, this should be a v plus c. And then now for some substitution. So we know that v is equal to inverse sine of u. So we'll use that fact and we'll start substituting that. So minus 1/2 inverse sine of u plus 1/4 sine of 2 times inverse sine of u plus c. Okay, and then u is equal to square root of x, and so that'll be our final substitution, and we should get the answer. So x inverse sine of square root of x minus 1/2 inverse sine of square root of x plus 1/4 sine of 2 inverse sine of square root of x plus c. Okay, this one was a doozy. Next one. 79. This should hopefully be less complex. The integral of inverse tangent of x. We'll use integration by parts on this one. Again. So, since we have the inverse tangent be the d, and then we'll just have 1 be the I. So when we differentiate, we get 1 over x squared plus 1. And when we integrate 1, we get just x. So plus minus, boom, boom. So we get x inverse tangent of x minus the integral of x over x squared plus 1. I think we can kind of go. What? I'm not screw whatever. Okay, and then, okay. Okay, and so, that's just a simple U sub. I won't actually show the work for that because, we've done it a bunch of times. We've done it a few times before already, so I'll just leave you guys to your own devices. 1 minus 1/2 natural log of x squared plus 1 plus c, and that is our answer. (80). This one's a piecewise function. Integral from 0 to 5 f of x dx, where f of x is equal to 10, x is less than, if x is less than 2, and 3x squared minus 2 if x is greater than 2. Well, here's what we'll do. Well, so this is equal to the integral from 0 to 2 of just 10 dx plus the integral from 2 to 5 of 3x squared minus 2 dx. And so, to simplify this, this will be 10x evaluated from 0 to 2 plus x cubed minus 2x evaluated from 2 to 5. And so this is going to be 20 minus 0 plus 125 minus 10 minus 8 minus 4 is equal to 20 plus 115 minus 4, 131 is the answer then. If I didn't do anything, if I didn't make any computational errors. And so we can go on to the next one. 81. We're 80% through. Already did. So this has been an experience, guys. It's been an experience. 81. The integral of sine of 1 over x cubed dx. We will let u equal 1 over x, which means u is equal to negative 1 over x squared dx. We only have x squared on the bottom and not x. Well, I'm sorry. We have x cubed on the bottom, not x squared, and so there'll still be like 1x left on the bottom, but we can let that equal u. But we can substitute that in with u. So what we're left with is the integral of u sines of u du. And this is a pretty straightforward integration by parts. We'll differentiate u and we'll integrate sine of u. 1, 0, negative cosine of u, negative sine of u, plus minus. Okay. And so our answer would be negative u cosine of u plus sine of u plus c. So minus 1 over x cosine of 1 over x plus sine of 1 over x plus c. That's our answer for this one. This next one is 82. The integral of x minus 1 over x to the 4th minus 1 dx. Well, we can do some factoring here. Because we can take this to be, if we factor the bottom, we get integral of, the bottom becomes x minus 1 times x plus 1 times x squared plus 1. That's just applying difference of squares 2 times. You can validate that for yourself. And then x minus 1 top, these two cancel. And so we are left with the integral of 1 over x plus 1
times x squared plus 1 dx. Okay, and so we'll do partial fractions on this one. So a over x plus 1, and then b over x squared plus, sorry, bx plus c over x squared plus 1 dx. Okay, so 1 is equal to a times x squared plus 1 plus b times x squared plus x plus c times x plus 1. Keenan, we are on problem 82 right now. And so, let's have some equations now. So, we'll start with x squared. 0, there aren't any x squared, so it'll be a plus 0 is equal to a plus b. There aren't any x's, so that's also going to be 0, so it's going to be equal to b plus c, and then there is a 1. There is a I guess a constant. So 1 is equal to a plus c. And then we have to solve for each of them. It's going to be 1/2 for A, 1/2 for C, and then minus 1/2 for B. Okay. And so, what are we left with? We're left with an integral of 1/2 over x plus 1 plus, minus 1/2 over x squared, 1/2 x over x squared plus 1, and then plus 1/2 over x squared plus 1. There is a reason I separated these, and that's because we can actually integrate both of these two terms individually. We can use u sub on the left one, and we can just kind of directly use the inverse tangent on the right one. So let's do that. Is equal to 1/2 natural log of x plus 1 minus 1/4 natural logs of x squared plus 1 here, and then plus 1/2 inverse tangent of just x plus c. Okay, 83. Integral of square root of 1 plus x minus 1 over 4x quantity squared. Let's just kind of expand this out. If we expand this out, we get 1 plus x squared minus 1/2 plus 1 over 16x squared. And so if we actually add the 1, we get something very similar. We get x squared plus 1/2 plus 1 over 16x squared. This actually, it's so similar in fact that we can actually factor it just like the first one. What we factor it into? Well, we factor it into square root of x plus 1 over 4x squared dx. And so the square root and square cancel, so we're just left with integral of x plus 1 over 4x dx. It's pretty easy. So it's equal to 1/2 x squared plus 1/4 natural log of x plus c. 84. The integral of e to the tangent of x divided by 1 minus sine squared of x dx. let's use some identities, because 1 minus sine squared of x looks surprisingly like cosine of x, cosine squared of x, which it is. So the integral of e to the tangent of x over cosine squared of x. So the next step, so we just kind of have to look at it from a different point of view, because we have a tangent of x on the top, and so when there's a tangent, you typically want there to be secant. We actually do have a secant, because 1 over cosine squared of x is just secant squared of x. And so we'll bring the cosine squared to the top, and so we actually get e to the tangent of x times secant squared of x dx. And then now we can just kind of use u sub. So u is equal to tangent x, which means du is equal to secant squared of x dx. Which actually makes that makes it very easy to simplify this. We just, the integral of e to the u du, so that's e to the u plus c, or e to the tangent of x plus c. Woo. Okay. Let's go on 85. Okay, 85. The integral of the inverse tangent of x over x squared dx. I would say probably, I would go ahead and say that, integration by parts is probably the way to go for this. So we'll differentiate inverse tangent and integrate 1 over x squared as usual. What do we get? Well, we get 1 over 1 plus x squared, no surprises there. And then we integrate, we get negative 1 over x. Okay. Okay. Okay, yeah, so plus, minus, we'll do that. Okay, and so we get minus 1 over x, inverse tangent of x, plus the integral 1 over x times 1 plus x squared. They practically give us the partial fractions for this one. They really do. So we'll let's become the integral of a over x plus bx plus c over 1 plus x squared. I don't really feel like writing all of that out. We'll just writing the negative 1 over x tangent, inverse tangent x again, so that's why I'm going to do that. Okay, so 1 is equal to a times 1 plus x squared. Well, we've done this before, haven't we? Not quite. Okay. Plus b times x squared plus c times x. And so for the x squared, 0 has to equal a plus b. 0 has to equal c, because that's the only one with an x in it. And then 1 has to equal a. So a is equal to 1, b is equal to 0. Sorry, wait, no. B is equal to negative 1. C is equal to 0. There we go. Okay, let's proceed from here. So is equal to negative 1 over x times the inverse tangent of x plus the integral of, well, just 1 over x minus x over 1 plus x squared dx. So this is fairly straightforward. So we get negative 1 over x inverse tangent of x plus natural log of x minus 1/2 times the natural log of 1 plus x squared plus c. Ooh. 86. It looks tougher visually, but it really isn't. Inverse tangent of x over x squared plus 1 dx. Wow, we can just do a u sub. U equal tangent inverse tangent of x. Du becomes 1 over x squared plus 1. I wonder where we've seen 1 over x squared plus 1 before. Oh wait, it's just the denominator. So this actually just becomes integral of u du, which is going to be 1/2 u squared plus c, or 1/2 inverse tangent of x squared plus c. That's nice. 87. The integral of natural log of x squared dx. What's the best approach to this? Yeah, let's do some u sub. I'm sorry, not u sub. Let's do some integration by parts. We'll just let the whole thing be what we're differentiating. And let's just let I be 1. So when we differentiate here, we get 2 natural logs of x over x, I think. And we integrate it, we just get x. Well, we can just stop it here, I think. And so we get x natural log of x squared minus, well, actually just the integral of 2 natural logs of x dx. Which we know that the integral of natural log of x is x ln of x minus x. That we can use integration by parts to prove it, or you can just memorize it, because it appears a lot. And so this will be our final answer. Yeah. Ooh, the final page. The integral of the square root of x squared plus 4 quantity over x squared. We can... I don't know where to appear the integral of sine squared. It wasn't really anywhere in the past, so I don't really know. Anyway, we're gonna do a nice trig sub here. Let's let x equal to 2 tangent of theta. Means dx is equal to 2 secant squared theta d theta. Okay. So when we put this in, we'll get that this is equal to the integral of square root of 4 tangent squareds of theta plus 4 over tangent squared of theta times 2 secant squared of theta d theta. So if we decide to simplify this, we will get I will be right back. Okay, sorry. Um, hmm. Okay, this one is kind of weird because, hmm. It's just kind of weird because you would end up with 4 secant cubed on the top, and that's kind of an awkward thing to have. But let's go with it. Let's try it. So integral of this would be equal to integral of 4 secant cubed theta over tangent squared theta d theta. So if we split this up into its sine and cosine representations, though, we get that this is actually going to be equal to 4 times the integral of 1 over sine theta times cosine theta d theta. We've encountered this same expression before, and so we're going to let the 1 equal sine squared plus cosine squared. And so really, this will be equal to 4 times the integral sine squared of theta plus cosine squared of theta over sine theta cosine theta d theta. And so we can split this up into 2 fractions. So this integral of, well, the first one will be sine over cosine. So this will be tangent theta. And the second one will be cosine over sine. So this will be cotangent theta. And so finally, we put this all together. 4 times the natural log of secant theta minus 4 times the natural log of cosecant theta plus c. Whew. That's 88. 89. This one's quite similar, but also very different. The square root of x plus 4 over x dx. We'll let let's let u equal the entire square root part, x plus 4. That means du will have to be equal to 1 over 2u again. This is a very useful property of square roots and their derivatives. And so this means we'll also up here note that x will be equal to u squared minus 4. So just keep that in mind. And then, okay, so if we put this all together, what we get is the integral of 2u squared over u squared minus 4 du, which is actually kind of nice because then we just use long division on this to get 2 plus 8 over u squared minus 4 du. Right? Wait a second. Oh frick! I messed up on 88. Sorry guys. I forgot to substitute the theta back in. Okay, yeah. So remember that theta is equal to inverse tangent of x over 2. This means this is actually equal to 4 natural logs of secant of inverse tangent of x over 2 minus 4 times the natural log of cosecant of of inverse tangent of x over 2 plus c. There we go. That's fixed now. Okay, back to 89. Wait, no, frick. I know it's another mistake. I'm sorry, this should be sine squared. Oh, that's not good. And so reality is this, okay, yeah, so in reality all my steps here kind of just funk. Okay, so this would be equal to, 4 times the integral of, secant theta plus, what would that be? What? Cosecant theta, cotangent theta? D theta? Okay, so this would be equal to, 4 times the natural log of secant theta plus tangent theta plus 4 times minus 4 times cosecant theta plus c. So, it's equal to 4 times natural log of secant of inverse tangent of x over 2 plus x over 2 minus 4 times cosecant wait, oh come on, sorry, there's a 4 here, these around here, these all get canceled out. Okay, it's cosecant of inverse tangent of x over 2 plus c. Okay, that one was kind of that was not great, that one. Okay, yeah, so we're left with this. For this one we can then partial fraction this one. I won't really, I mean the details are this they aren't really like particularly noteworthy. It's a relatively simple partial fraction. So it'll be u plus 2 on one of them, and then u minus 2 on one of them, and then it'll actually be minus 2 on this one, and then plus 2 on this one. Yes. And so we get 2u minus 2 natural logs of u plus 2 plus 2 natural log of u minus 2 plus c. Substitute u back in. We get 2 square roots of x plus 4 minus 2 natural logs of square root of x plus 4 plus 2 plus 2 natural log of square root of x plus 4 minus 2 plus c. This problem, I was fixing a lot of the errors in 88 because I made a lot of them that I noticed while I was fixing one of the ones that I looked at. Now I'm doing 89, I just kind of finished it, so I should be doing 90 now. So we're almost there, really. Okay, the integral from 0 to pi over 2 of sine cubed of x over sine cubed of x plus cosine cubed of x dx. Okay, so let u equal pi over 2 minus x. That means du is equal to negative dx. And so this is equal to the negative of pi over 2 to 0 of sine cubed of pi over 2 minus x minus... Wait. Yeah. Pi over 2 minus u over sine cubed of pi over 2 minus u plus cosine cubed of pi over 2 minus u. See, now, the special thing about this is that, remember that sine of pi over 2 minus x is equal to x. Sorry, sine of pi over 2 minus x is equal to cosine of x. And then, likewise, cosine of pi over 2 minus x is equal to sine of x. And also remember that we can, negative of the integral from a to b is equal to the integral from b to a. And so we'll use both of those facts combined to get that this integral is actually equal to, from 0 to pi over 2, of cosine cubed of u over sine cubed of u plus cosine cubed of u du. Here's something interesting now. We know, see, u is kind of there as a, when we have definite integral, and they have the same bounds, and, well, sorry, if we have two definite integrals and they have the same bounds, and they're equal to each other, well, they're just the same thing. It doesn't matter what variable they use, they're kind of the same. So we can just set the so instead of u, we'll have it be equal to x, and it'll still be the same. So really this is the exact same thing as pi over 2, from 0 to pi over 2 of cosine cubed of x over sine of cubed of x plus cosine of cubed of x dx. And so we'll let all of this just equal like to s. So that's the sine of cubed one on top, that's equal to s. The cosine of cubed one x on top, that's also equal to s. All of it is s. Now let's add the one with sine of cubed on top to the one with cosine of cubed on top. And so what we get is we get 2s is equal to the integral from 0 to pi over 2 of sine cubed of x plus cosine cubed of x over sine cubed of x plus cosine cubed of x dx. And so they actually just cancel out just of 1. So in fact 2s is equal to pi over 2, which means s is equal to pi over 4. Cool. 91. Yeah, so this one's 91 short and sweet, I'd say. Integral of x over 1 plus x to the 4th dx. Okay. We'll let u leave an x on top, so we want u to be equal to x squared. And so then du is equal to 2x dx. Okay, so the top x is canceled out. But the bottom has an x to the 4th. Well, x to the 4th is the same thing as x squared. And so what we write this as, this is equal to the integral of, well, 1/2 over 1 plus u squared du. Wow, that's pretty nice, isn't it? And so this is just equal to 1/2 times the inverse tangent of u plus c is equal to the 1/2 times the inverse tangent of x squared plus c. This is 91. I'm doing 92 now. I'm going to move on to 92. the integral of e to the square root of x dx. Let u equal to square root of x, which means well, du is equal to 1 over 2u dx. And so this is equal to the integral of 2u e to the u du. Integration by parts. D I, we'll let d equal 2u because we don't really want an exponential there, and so we'll place the exponential in the I. It becomes 2, it becomes 0. This basically stays e to the u the entire time. Plus, minus, cross, cross. You know the drill. Okay, and so this is equal to, well, just 2u e to the u minus 2e to the u plus c. U is equal to square root of x, so we gotta make sure to substitute that back in. It's equal to 2 square root of x, e to the square root of x, minus 2e to the square root of x plus c. How did the camera quality go down so significantly? The problem number right now is 92. Oh, actually, camera might be placed too high, actually. And that's probably it. (93) The integral of 1 over cosecant cubed of x dx. This is just equal to the integral of sine cubed of x dx. I mean, that's not anything special, is it? And so by some trigonometric identities, this is equal to sine of x times 1 minus cosine squared of x. We'll let u equal to cosine of x, which means du is equal to negative sine of x dx. And so this is equal to the integral of negative 1 plus u squared du. Yeah. So when we integrate this, we get 1/3 u to the u cubed minus u plus c. We substitute u back in. That's just 1/3 cosine cubed of x minus cosine of x plus c. (94) The integral of sine inverse of x over square root of 1 minus x squared. If we just let u equal sine inverse of x, then that means du is automatically equal to 1 over square root of 1 minus x squared dx. And so this is just equal to the integral of u du, which is equal to 1/2 times u squared plus c. So in all, it's 1/2 times the inverse sine of x squared plus c. Let me see if I can raise this up for the next few things. Maybe camera quality will be. Worked out. So question 95, the integral of the square root of 1 plus sine of 2x. plus c. Plus c? Sorry, that's, whoops, dx. We might as well expand it. Why not? So this is equal to the integral of the square root of 1 plus 2 sine of x cosine of x dx. Oh, wait a second. So we established previously that the 1 plus sine of 2x is actually the same thing as sine of plus cosine of x quantity squared. And so in fact, if we let 1 equal to sine squared plus cosine squared of x, we actually get the integral of sine squared of x plus 2 sine of x cosine of x plus cosine squared of x. If we factor that, then of course we get the integral of sine of x plus cosine of x squared dx, or in other words, just the integral of sine of x plus cosine of x dx, which is equal to sine of x minus cosine of x plus c. (96) The integral of the fourth root of x. Dx. I guess this is like supposed to, like, I don't know, calm you down. I don't know. This is equal to x to the 1/4 power dx. So like power rule gives us that this is just equal to 4/5 times x to the 5/4 plus c. That's fairly easy. The integral of 1 plus 1 plus e to the x, 1 over 1 plus e to the x. This is equal to the integral of well, okay, so if we can do plus e to the x on top here and then do minus e to the x on top of here. If we do that, we get 1 plus e to the x over 1 plus e to the x minus e to the x over 1 plus e to the x dx. And so this is just equal to 1 minus e to the x over 1 plus e to the x. What's nice about this is that we can allow u to equal 1 plus e to the x now, which means du is equal to e to the x dx. And so really what we have is the integral from 1 minus 1 over u du, or wait, I'm sorry. So it's equal to x minus the integral of 1 over u du, which is equal to x minus natural log of u plus c, or in other words, x minus the natural log of 1 plus e to the x plus c. Divide the top and bottom by e to the x? Is that something that helps you? Oh yeah, because you get u to the negative x on top and u to the that's pretty smart. Okay, so 98. Oh, what is 98? It's gonna take some room. Let's get another one. 98. 98 is the square root of 1 plus e to the x dx. Oh, this one's a weird one. I don't know, we can try, let's try some stuff, shall we? Let's let u equal to 1 plus e to the x, which means du is equal to e to the x dx, which also means that, oh yeah, that means e to the x is equal to u minus 1. So really, what we have is that du is equal to 5 more? Oh yeah, I'm going to do 5 more. Well, 4 more. 5 more? I don't know. So really, du is equal to u minus 1 dx. So what do we have? We have this equal to integral of square root of u over u minus 1. Okay. I don't know, let's let, maybe we'll let v equal square root of u then? I don't know, or it seems worth a shot. That means dv is equal to 1 over 2v du. Yeah, so let's try this out. And this is equal to the integral of 2v squared over v squared minus 1 dv. Just be dvu, which is actually that helps a lot. Yeah, because then we can just do we can do long division on this, and so this is really equal to the integral of 2 plus, I think 2 over v squared plus 1. I'm sorry, 2 plus 2 over v squared minus 1 dv. Okay, and then this isn't too bad from here. It's a partial fraction decomposition. So 2 plus, we need something for v minus 1, and then we need something for v plus 1. This is going to be 1, and then it's going to be minus 1. Okay. dv. Okay, and then you can verify that partial fraction decomposition works. You just have to combine denominators. Okay, and so yeah, and now we do. We just integrate it now. So it's equal to 2v plus the natural log of v minus 1 minus the natural log of v plus 1 plus c. Now we can do a whole bunch of substitution, get back to where we originally were. So this is equal to 2 square roots of u plus natural log of square root of u minus 1 minus natural log of square root of u plus 1 plus c. And then since we know u is equal to 1 plus e to the x, what we can do is this is finally equal to 2 e to the x plus 1, or 1 plus e to the x, doesn't matter, plus natural log of square root of e to the x plus 1 minus 1 minus natural log of square root of e to the x plus 1 plus c. $99. Yeah, sure. Actually, okay. I know is the integral of square root of tangent x over sine of 2x dx. Huh. maybe it would be helpful to rewrite this using sine and cosine. So really this is equal to the square okay, square root of sine of x over cosine of x over 2 sine x cosine x dx. Okay, we can't let it. We can't let u equal sine or cosine because that would there's no sine or other cosine to cancel that out with. Well, maybe u equal tangent of x? Maybe it's secant squared of x. No. I gotta try something. Maybe I'll just let u equal square root of tangent x. I don't know. And this du is equal to secant squared x over 2u dx. If we do that, so the integral becomes equal to, so the square root of tangent x on the top becomes just a u. Then we have to multiply by 2u on the, since over here we have that. So we get 2u squared and then divided by 2 sine x cosine x times secant squared x dx to du. Well, okay, so we can move the secant squared on top. So maybe 2 squared times cosine squared x over 2 sine x cosine x dx. Oh wait, oh okay, yeah. So we have a cosine over sine, but that's like the same thing as 1 over sine over cosine. So that's the same thing as like 1 over tangent. So what we really have here is we have integral of, well, I'll remove the 2 from the front since they cancel out each other. We have integral of u squared over tangent x dx, right? However, we know from up here that u is equal to the square root of tangent of x. Because of that, we know that tangent of x is equal to u squared. So this is actually the same thing as just the integral of u squared over the integral of u squared. Wait, so that's just the integral of 1 du. Really? Okay, so that's equal to u plus c. So that's square root of tangent of x plus c. Okay, sure. Okay. What problem are we on now? We are on 100. Okay. the integral from 0 to pi over 2 of 1 over 1 plus sine of x dx. Let's try multiplying by the conjugate. So if we multiply the conjugate, so if we multiply the top and bottom by 1 minus sine of x, we get integral from 0 to pi over 2, of course, of 1 minus sine of x over 1 minus sine squared of x. Well, we know that 1 minus sine squared of x, that's the same thing as cosine squared of x, so yeah, sure, Akshay, if you want to provide me with the 102nd integral, go ahead. I'll take it from you. Okay, and so now we can just decompose this into two fractions. So we have, well, 1 over cosine squared is the same thing as secant squared. And then sine x over cosine squared of x is the same thing as secant tangent. You can check that by just turning those into cosine and sine forms. And so this is equal to these are both actually really easy to integrate because it's just tan x minus secant x from 0 to pi over 3? Pi over 3? Pi over 2. Okay. So, wait. Something wrong here. Oh, yeah, because it goes over a discontinuity when we include that. Okay. Limit as b approaches pi over 2. Screw it. So, okay. Okay, of tangent of b minus secant of b minus well, it's just 0 minus 1. Okay, so this is equal to this is the same thing of sine of b minus 1 over cosine of b. So the limit as that approaches pi over 2. Oh, okay, so please don't tell me we have to use L'Hopital's rule for this. Please tell me there's an easier way. Is there an easier way? I have to do this. L'Hopital's rule is okay, so we take the derivative of the top, that's cosine of b. Over top, that's sine of b. And so this should finally get us to somewhere we need to, something we would like to go to. So this is equal to 0 over -1 is equal to 0. Yes. So what we really have is equal to 0 minus 0 minus 1. Or in other words, just 1. Okay. I think that's 1. At least I hope that's 1. Anyway. 101. The integral of sine of x over x plus natural log of x times cosine of x. All this one's interesting, actually. Dx. Well, there's literally no trick that I would ever want to use on this, because this answer is just sine of x ln of x. Because a product rule. I mean, you can try it, because, like, when we differentiate sine of x times natural log of x, we get, when we differentiate sine of x, we get cosine of x, so cosine of x times ln of x. When we differentiate ln of x, we get 1 over x, so sine of x over x, and then that's how we get it. Oh yeah, make sure to do plus c. And then, yeah. Akshar, give me that 102nd question. Akshar, where are you? Come on. No, I will not be doing 103rd. I just want 102nd one. If you guys are going to give me one, I'm just going to do the one I already prepared. Last call. Okay, screw it. Okay, well that concludes my stream then. We're done. Well, how many people are 29 people? Jesus. Okay. So yeah, this is the 102nd question. The integral from -infinity to infinity of e to the negative x squared dx is equal to the square root of pi. I'm gonna do a face reveal. Kind of dark. Here, let me see what I can do.
I know. Okay, stream's over. I'm gonna cancel this in about 10 seconds.